I w tym czasie niech pan puści wszystkich Bartłomiejów Glinów na hostu i będziemy widzieć, gdzie jest profesor, nie? Szuszkiewicz. Okay. Good morning, hello.
Good morning, everyone. Dobre jutro. Guten Morgen. Dzień dobry wszystkim. I am very pleased to welcome all the participants to the second edition of the International Electronic Conference on Soil Science. My name is Waldemar Spychalski, and I am the chairman of the organizing committee. We organize this event to celebrate the upcoming World Soil Day. The main topic of the conference is the impact of climate change on soil degradation, with a focus on soil salinization, soil organic carbon loss, and agriculture drought on soil water retention. This event is organized by the Department of Soil Science and Microbiology and the Poznań branch on Soil Science Society of Poland. I have a pleasure to announce that our conference patronage of Professor Krzysztof Szuszkiewicz, rector of Poznań University of Life Science, and Zbigniew Zagórski, the president of Soil Science Society of Poland. I strongly believe that this meeting will take us closer to the crucial issues related to soil degradation and its protection. I wish for all of us a nice and successful time. I am sure that the presentation will attract your interest and encourage to active participation in the discussion. Thank you very much. Now, I would like to introduce Dr. Bartłomiej Glina from our department, who will be a moderator of today's meeting. At the beginning, he will present the conference program and rules of the meetings.
Thank you very much. Thank you very much, Professor Spychalski. It is really an honor, and I am so delighted to be a part of today's event. I'm really glad that I can share the time with you today. So, before I start with describing the rules and the program of the conference, firstly, I would like to announce the welcoming speech. The first person I would like to announce will be the rector of the Poznań University of Life Science, Professor Krzysztof Szuszkiewicz, but at the moment we have some technical problems and we are not sure that Professor Szuszkiewicz is with us at the moment. We have to wait a little bit, so sorry for that. Maybe, Professor, you can write something on the chat that you are with us, and then we will make you a host of this meeting, and we will be sure that it is you. So we are very sorry for the problem at the moment, but I'm sure that we will solve it soon. Director, if you can write something in the chat box to confirm that you are with us, because we cannot see you on the list of the participants at the moment.
Przedstawić po kolei. I tego jako będzie przedstawienie, tak. Puścić i tego, i dzień dobry za chwileczkę.
Okay. But we have some message in the Q&A section, maybe there is some pointed that this is Professor Szuszkiewicz. Yes, we have him. Okay, so fine. Rename, Sergei Goriasz. Okay, soon we will connect with Professor Szyszkiewicz. Again, sorry for this situation, for this inconvenient situation. What happened? Okay. And maybe if we still have some time, please confirm that Professor Zagórski is with us, the president of the Soil Science Society of Poland. Also, you can use the Q&A section or the chat box. We have some problem with the participants list, that's why some problem occurs right now. Okay, now we have connection with Professor Szyszkiewicz, thanks. So, dear Rector, welcome to our conference, and please take a few words. It is nice to see you.
Hello, I'm happy to welcome participants of the Soil Science Conference at the Poznań University of Life Sciences. First of all, congratulations for organizers, which are so active that even now during the difficult pandemic period, they managed to organize such a great event. I'm very happy that the activity is carried on at our university. So I would like, I also would like to underline that a topic of the conference is extremely important because we are under the dramatic climatic change period, and we need current knowledge on this topic. We need a lot of verified information about the undergoing processes. I believe that this conference will help us to understand more about this concerning soils, which are fundamental element of the processes in ecosystems. So I wish all participants a great time. I will follow the interesting presentations.
Thank you. Thank you so much.
Participants.
Thank you so much, Mr. Rector, for this nice welcome speech. And now, if the Professor Zagórski, the president of the Soil Science Society of Poland, still is with us, we can skip to him right now. So, Mr. President, are you with us? Can you write something on the chat box or in the Q&A section? Because we cannot see you in the participant list. As always, something happened, the technical constraints, but we have to struggle with this. Złapać, a tamtych ja będę później atakował.
No, po choińskim.
Professor Zagórski, are you with us? Please write something on the chat box, because we have to know which name is yours, because unfortunately all of the officials use my link to attend to the conference. Unfortunately, it was also my mistake that I sent it yesterday to you.
O, mamy chyba profesora na czacie.
Okay, so we will try. We will make you a panelist right now.
Jest chyba pan profesor Zagórski na czacie już. Z innego chyba konta korzysta.
Artur Pepędziwia, proszę zrobić. Tu zrobić go jako ten. Okay. Now we have the solution for this situation. Okay, soon you will have the unmute. Okay, well, now we have the connection. I can see it on the main screen. Fortunately, we are close to connect Professor Zagórski. So once again, I really like to warmly welcome the president of the Soil Science Society of Poland, Professor Zbigniew Zagórski from the University of Life Science in Warsaw. Welcome. Please unmute your microphone. We do not hear you. Please unmute the microphone.
Hello?
Okay,
No.
yes, right now
It's okay. Good morning, and maybe good afternoon for some listeners. Sorry, I have some health problems. It is a disease effect on the COVID-19 that I had a month ago. Sometimes it clogs me up. And I can't speak. So my speech will be very, very short. Mr. Rector, Mr. Chairman, thank you for the opportunity to talk and say a few words. As the president of Soil Science Society in Poland, I warmly welcome all participants of the conference. This conference is organized on the occasion of World Soil Day 2021. Our society, which is a member of International Union of Soil Science Societies, devotes a lot of attention to the Soil Festival. We know that it is also solemnly celebrated by soil scientists around the world. We have a lot of information about various events currently taking place or planned for the near future in Poland and in the world. One such important example is our electronic conference today. I'm very happy that this conference, this is another initiative of my colleagues from the Poznań branch. This is the second edition. Sorry. Is met with so much interest in our country and also with recognized abroad. So these participants, following the conference program, I'm sure that during these few hours, you will be talking about important current soil problems. First of all, in the context on visible problems on climate change in the world. I wish you all fruitful deliberations. I'm convinced that the present difficult pandemic reality, we can also find a lot of scientific and personal satisfaction. I wish all participants and their families good health. Please take care of yourself. Thank you for your attention.
Thank you very much, Mr. President. It was a very nice talk, an open speech. So, dear all, now we can officially say that the conference, the second edition of the International Conference on Soil Science, is officially open. Still, we have some couple of minutes for the first presentation. So now I would like to shortly introduce the rules of the meeting. So the conference, as you can see, is held on the Zoom platform, and parallel to the presentation, also we have the live streaming on the YouTube channel, on the official YouTube channel of the Poznań University of Life Science. in the case of the presentation, each of the speaker have 20 to 25 minutes for the presentation. And after that, we ensure about 5 to 10 minutes for eventual question and discussion. All participants of our conference are allowed to ask questions by using the Q&A box, which is visible on the right side, below the main screen. And the number of questions which are limited by time, I will read all of them according to the order in which they appear in the Q&A section. Of course, due to the limit, some questions will be not asked directly to the speaker, and that is why you will have the opportunity to make it via the email after the conference. What else? I am sure that maybe we'll have also some connection problem as we have at the beginning of this conference. So that's why some delay maybe should occur as well. But let's hope that everything will go in a proper way. So right now we are almost at the time to begin the first presentation. And the first presentation will be given by the Professor Bogdan Chojnicki. The presentation title is Changes of Soil Under New Climate. Professor Chojnicki is a senior researcher at the Department of Ecology and Environmental Protection at the Poznań University of Life Science. Professor Chojnicki is the president of the Poznań branch of the Polish Geophysical Society. The main goal of his research activity are the interactions between ecosystem and the atmosphere. He deals mainly with the exchange of heat, water, carbon dioxide, methane between peatlands, forests, and agroecosystem. He is specialized in the application of micrometeorological techniques in field conditions. So please join me in welcoming Professor Bogdan Chojnicki. Bogdan, the floor is yours.
Thank you very much. Good morning. Good morning without any problems, further problems, technical problems, but I think this is, let's say, normal situation. I was asked by Bartosz to present some general overview, on climate change and the soil. I'm sure that 20 minutes is not really enough to do it, because in fact we are facing of various issues. This day, Soil Day, is about the salinity of soils, but if we talk about the climate change, we are facing of many
but we do not see the full screen.
Oh, why? I see.
I don't know why, but we see only the work mode of the PowerPoint.
I just started. Stop share. It looks like technical issues are back.
Problem today.
Okay, how about now? Maybe, how about now? Do we?
Okay, now it's perfect.
Are you able to see it? Okay.
Yes. Now we see the full screen, so you can continue. Sorry.
Okay, so in general, as I said, this is very complex issue. If we talk about the climate change and in relation of the soils, we know that soil is one of the most important element of biosphere. Sometimes we just simply forget about the soils, and in many cases we just simply think that soil is simply dirt. It was a little bit witty for me to hear that first president of United States who called soil was Barack Obama. Before, it was only considered as a dirt, and I think sooner or later all of us will see that. Okay, my presentation is stuck. No, okay. Sooner or later we are going to change the vocabulary from dirt to soil, due to the fact that soil is just simply source of our food, and it of course plays many other very important roles. Something about the climate change. These are results, or these are findings presented in the last IPCC report, where we see very clearly on the right chart that the impact of human being is really visible. The weather or climate globally wouldn't be very different but the presence of human being, actually the emission of a lot of greenhouse gases is one of the reasons why we are facing the changes. And what is also very interesting, we already have our own observations, and we already can see that, for example, hot extremes, heat waves, are present mostly on the whole globe. There are only few regions where those hot extremes are not present, or maybe there is not enough data to say if they are there or not. But for example, Eastern Europe, this is, I mean, on this figure, this is part of our region. We already observed the hot extremes. It has the impact also on the functioning of the soils. If we talk about the heavy precipitation again, our region, Eastern Europe, is also facing the increase of heavy precipitation. We know already that this heavy precipitation makes an impression, especially in media, but in fact, there is not really, it is not so positive in the context of maintenance of proper properties of the soils. If we talk about the agricultural and ecological droughts, the situation is not really clear. We still do not know if we face the agricultural and ecological droughts or not in our region. Of course, Mediterranean region will face or faced already such situations, but here we are not very sure. I would say these observations are still, let's say, statistic overview, and let's believe that nothing will happen, and we are not going to have more droughts. However, I will show you later the picture or the figure that was rather, let's say, projection that will let's say, help us to understand what will happen in the future, also with the soils. Here we have some simulations. We know that those simulation depends on the strategies of carbon dioxide and other gases reduction. So in fact, it depends on us. We are not talking about the forecast, but rather about the projection, because it's still, the future is always depends on us, on our activity. So generally speaking, we expect that within next 20 years we are going to reach the temperature increase by 1.5 Celsius degrees, and this is simulation. The worst and let's say the less optimistic scenario is 2 Celsius degrees. But what we really afraid, if we do not change our civilization paradigm, we are going to face this type of temperature increase. And as you see, whatever simulation we have here, the Poland is under the temperature increase. And in fact, last 10 years, increased the average temperature in Poland by 0.8 Celsius degrees. We are already facing a global warming. If we talk about the precipitation estimations, the situation is not so clear, because in fact, we must remember that the increasing of temperature increases the dynamic of water cycle. Simultaneously, it will create the areas where water will be more available, and the area where water availability will be really shrinked. And in fact, our region, I would say Poland, is in the area where there will be not much change if we talk about the precipitation. but the regions like many Mediterranean regions of Europe will suffer droughts. Of course, if we increase the temperature, if we are not going to stop our emissions, the situation will be more and more complex. There is also interesting simulation regarding the total column soil moisture change. It is expressed in standard deviation. And again, the areas where the precipitation will be limited, the soil column moisture will be negative, and the places where the precipitation will increase, the moisture of soil will increase. But again, I must say that this is not just increase the water amount, because in many cases it will be realized by very heavy rains, which means the soil is not going to soil will be sometimes under simple pressure. And here, this is the estimation that was done by my colleague Bartosz Czernecki from Adam Mickiewicz University. And this is the climatic water balance. This is actually, in this case, this is simply precipitation minus evapotranspiration from Poland. Very simple modeling based on the assumption that we are not going to change our emissions. We call it business as usual. And as you can see, this red line shows the trend of this climatic water balance. And sooner or later, the climatic water balance in Poland will be shrinked. We know already that in this case, the climatic water balance is something what is showing the water that will outflow from Poland, which means that our streams and rivers will be more and more empty of water, and it has not much to do with the soil capacity, soil retention. However, if the climatic water balance is going down, it means the probability of drought is increasing. So from the perspectives of such analysis, we should expect that droughts in Poland will be more and more visible. Of course, this is a question how our agriculture and how our spatial management will react to this information. What are the expected effects on soil? There are at least four effects. Four changes we should expect in the future: increasing temperature, increasing of carbon dioxide concentration, increasing the rainfall, and of course decreasing the rainfall. It depends on the region. And if we talk about the increasing of temperature, we must say that this is the increasing of the energy of any processes, which means if we talk about the organic matter, then we should expect the loss of organic matter. And in many cases, especially during the droughts, we should expect also the reduction of moisture content. That is directly linked with soil productivity, but also the other processes, just soil processes. Of course, we should expect a reduction in labile pool of soil organic matter, because it will be this pool will be simply under the stress. And one of the reasons why we expect this reduction is just simply increase of mineralization rate. We should also expect the loss of soil structure. Soil organic matter is one of the elements that maintains proper soil organic structure, especially in the light soils. And this mineralization rate increase, of course, will end up with a soil respiration rate. I think Stefan Glatzel is going to say more about it, but I'm going to show you only one experiment that was conducted by my colleague Marcin Baran at our former department. It was done by automated chambers that enabled us to estimate the carbon dioxide exchange on the bottom of the Tuczno forest. And if you look at this figure, where we have dependency between the emission of carbon dioxide and the temperature, we see that this dependence is non-linear, which means the increase of temperature is going to increase the CO2 efflux. And I think this is very, let's say, intuition says that it's supposed to be like that, but this curve instead of line makes us a little bit scared, because it means the process is not very proportional. Process intensity is not proportional to temperature change, which means another reason to be really worried about the future of soils also in the forest. If we talk about the increasing of CO2 concentration, then we say something what will be a little bit opposite to what I said before, because we should expect that biomass will increase due to the fact that many plants, not all plants, only C3 plants are more effective in terms of photosynthesis under higher CO2 concentration. On the left figure, you see, this is a glass dome run by our colleagues from Czech Globe in Brno, in Czechia. And they found out that the increasing of carbon dioxide is just simply provoking the development of roots. This is this bad message to people who expect that increase of CO2 concentration will provoke the increase of productivity, food productivity. In many cases, the plants are going to invest this captured carbon dioxide simply to the roots. So one of the reasons is that if they face the water limitation, then they are developing this tragedy of the increasing of roots mass, just to maintain the water availability secure system. Increasing of water use efficiency, as I said, it will be also observed just because the plants are going to act in more comfortable situation in the context of carbon dioxide. There will be more availability of carbon dioxide to soil microorganites, but if you link this conclusion with the increase of temperature, then you see that it will accelerate the nutrient cycling, which means the biomass will be more dynamic than before. It is really great challenge for the future, how to deal with the accelerated nutrient cycling. The increase of rainfall, of course, we should expect that increase of rainfall will impact both moisture and soil wetness, but increase of rainfall, especially heavy rains, it is also the problem of erosion, just the erosion that can really modify or even destroy the soils. We are losing some soils due to erosion, water erosion, and this process will increase if we are not going to adapt to new situation. And of course, nutrient leaching. This is what we expect if we increase the rainfall. Of course, there will be a reduction of iron or nitrates, and what is very interesting and very important, some of the region will observe the productivity, especially those arid region. Here we have, I think this is Arizona. Of course, this is the human-made irrigation systems, but we should expect that some areas are going to be more productive due to the increase of rainfall. And the last change that's supposed to affect the soil, that is the reduction in rainfall. Today, I think we should expect increase or enhancement of wind erosion from time to time, especially during the dry spring, when the soil is absolutely bare, free of vegetation. Then we see that strong winds are just removing the elements, mineral elements that are very important for the soils and their structure. And of course, the soil organic matter will be also removed by wind erosion, but also just because the reduction of rainfall creates the more possibilities for oxygen to penetrate the soil profile. And of course, dry soil is soil that is poorer in the context of nutrient availability. Soil salinization, it looks like this process is a process that is considered as most important for this soil year, and we should expect it if we expect both rainfall reduction and temperature increase. The soil salinity is very big challenge, because we know already that if you want to maintain especially food production in very arid areas, then you really must to flush the soil profile with water. The increase of temperature and reduction of rainfall will not help. It will rather make the situation worse. So what is the future challenges for soils? I would say there are many of them, but from my perspectives, I think number one is soil water balance, because in fact we are going to face of situation when this water balance will be more biased and sometimes destroyed by the climate change. And of course, soil's carbon balance, just because of organic matter is absolutely unnegligible element of the soil chemistry, soil structure, soil physics. So those two challenges, but probably many more, will face soils in the future change in terms of climate situation. Thank you for attention.
Thank you very much, Bogdan, for this very interesting presentation, and in my opinion, very important for the further part of our conference today. It was a kind of a great introduction to the next presentation, which we will hear later. And as now we have to view on the most important issue related to the climate effect on soil, in my opinion. And as you show the problem of the climate change effect on soil, we can say that it is quite holistic, and it is very hard to find a good solution to protect all of the important soil properties which are related to the food productivity, especially in the future for the growing population all over the world. Yeah. So I really encourage the participants to asking questions, because right now in the Q&A section, I do not see the Q&A section. Can you show me? Okay, we have one question in the Q&A box, so please, I will read it. So the question is, what kind of soil properties, especially changes, do you expect due to climate change and its eventual impact on the food production? Could you explain this? Do you understand the question?
Yes. If you, I mentioned several times about organic matter. the light soils or soils in general, soils capacity, both cations capacity and water capacity, of course, relies on the soil texture, which is made by let's say mineral fractions. But we always remember that organic matter is the second important element that creates both this cations and water capacity. If the temperature, temperature is increasing, which provokes the emission of carbon dioxide, it means the amount of soil organic matter can be reduced. And then we have two ways. The first way, for example, producing more organic matter and leaving it on the field, which happens from time to time. But we have to remember that sometimes we just say, okay, we use our field for biofuels production. Then we are collecting all possible biomass because we need to burn it, to combust it in our fireplaces. So in fact, organic matter will be really issue in the context of the soil structure, which means we have a big pressure on organic matter now due to the climate change, and then it will provoke our reaction. And this reaction, if this reaction will be not proper, then we are going to face the reduction of soil capacity, water and cations capacity, and of course the food production capacities. So from that perspective, I would say in long term, if we just think that monoculture or taking care only about the yield is the best way to the best attitude to manage the farm, I think from that perspective it will be a problem if we are not going to, especially on the light soils, we are not going to recognize how serious are the situation.
Okay, Bogdan, thank you for this really complex answer, but we still have another questions. At the moment, we have still four more questions. So I will start from the beginning of the list. So the question is from Christiana Obey Isaac Izoya, and she asked, it is obvious that ongoing climate change to be a difficult problem. In your opinion, what should our farmers do to prepare for the worst? Okay.
If we talk about the farmers, I think again the issue is the situation is very complex, because first, if you have a temperature increase and you are able to manage the water, then you have a chance to increase the productivity. But you have to really care about the management, and one of these elements is of course taking care about the soil, and I think this is a basic for food production in long term. But this is something what we say positive, let's say, perspective for farming. But there is also negative perspective for farming if you do not do proper management soil and proper management of your farm. If you have a weak soil, then you are facing a very serious issue how to deal with the soil. And at the end, because now I was just talking about the farm perspective. Just think about the global food market and the stronger and stronger impact of climate change. This creates a lot of tension and a lot of reasons to make a business on the food prices change, which means this is increasing the unsecure situation on the food market. And this is not only the question of farmer that is going to, let's say, he takes care about the business, he takes care properly, but if there will be any bias, if there will be a bias of climate change, it will be, then the farmers are going to face completely independent of them issues. For example, we are producing, let's say, meat, and then we are importing the food from somewhere, just soya, for example. And then there is a climate change strong impact on soya production, let's say in China. The price of soya is going to rise up, and then your economy here, let's say in Poland or I don't know, in France, is becoming under the very strong pressure. This is not only the issue that I'm going to save my food production. This is also the issue that whole food market will be under the tension.
Okay, thank you so much, Bogdan. We still have only 1 minute, so maybe one short question more, because there are several waiting for you, but we have only 1 minute. So the question from Jean Diata. Forecast technology is really highly precise. So why we are still being surprised by climate disaster? What do you think? But shortly, Bogdan, 1 minute you have.
I would say, okay, I'm going to answer from the perspective of soil. For today, we are just using 40% of terrestrial area for food production, farming production, which means 40% of soil surface is used for food production. There is no way to increase the size of the soils, which means we are just already we have farm maximum size farm. So now the only option is increase the production. And of course, we are going to do it using fertilizers now, the gene transfer, but the climate change is going to make a very serious question mark into this picture. And this is the problem.
Okay, thank you so much for your answers. So we are sorry that we have the time limit because there are a lot of questions, but now we have to go to another speaker. So once again, Bogdan, thank you once again for your very nice contribution to the conference. So ladies and gentlemen, now I will have a pleasure to announce the second presentation entitled Climate Change and Different Ways of Permafrost Affected Soils, Transformation, Practical Consequences. The presentation will be given to us by Professor Sergei Goryachkin, the head of the Department of Soil Geography and Evolution from the Russian Academy of Science. Professor Goryachkin plays many functions in national and international societies, among which the most important are the position of the Vice Chair of the Soil Geography Commission of the International Union of Soil Science, Chair of the Soil Genesis Geography and Classification Commission in the Dokuchaev Soil Science Society, and he is also the honorary member of the Soil Science Society of Poland. So, ladies and gentlemen, please join me in welcoming Professor Sergei Goryachkin. I hope that Sergei is with us, or we still have some connection problem. So unfortunately, we have some connection problem. So again, sorry to all of you that we have to wait for the connection with the speaker. Unfortunately, we cannot skip this speaker and go to another, because another speaker is not right now allowed to give us to the presentation, Professor Glatzel. So we have to wait for Sergei. Okay, now we have Sergei Goryachkin with us, unfortunately with my name, as you can see, but this is...
I'm here.
Okay, welcome, Sergei. It is good that you are with us. So we run your presentation and you can start to present your topic.
Okay.
But please turn on your camera if you can.
Yeah.
Okay, your presentation will be visible soon. Okay, so please.
Okay, I just want to begin that with that I'm very thankful for organizing committee to invite me as a speaker for this very interesting conference devoted to the International Day of Soils. So my presentation is climate change and different ways of permafrost affected soil transformation. Next. Next, please. Yeah. So I'm not the only one author of this presentation. So this is just a number of my co-authors. Next. So as Bogdan already showed, the difference in climate change takes place in our globe. So if in comparison with the global trends, you can see that the northern latitudes are anticipated much higher increase in global warming. Next, please. So there are some international projects. Of monitoring of circumpolar active layer, monitoring calm project. Active layer means the depth of every year thawing of permafrost, just the depth of soils. So you can see the large grid of such places. In Poland also have one point in the Spitsbergen and Svalbard. This grid covered, I think, all types of polar and high altitude territories with permafrost. And you can see that in spite for the general trend of air temperature increase, their reaction of permafrost could be pretty different. So just two examples from northeast of Europe in Vorkuta and northeast of Asia, it's Lower Kolyma. You can see that in Europe the active layer increase is much higher and much stronger than in continental areas of Northeast Asia. Next, please. Next. I'm sorry, I didn't remove the animation. Next. Oh, okay. So just the energy of climate change can be different for soils. And there could be the active layer deepening, just measured by calm projects. So it is frontal change of permafrost affected soils. But at the same time, we can see that not only frontal change exists, but also so-called fractal change, when we can see the very intensive thawing of permafrost, but in a rather small portion of soil areas. Next, please. So this is just example from the same point, photographs for more than 20 years. You can see just that soil cover destroyed by thermokarst, and just a number of soil areas decreased in comparison with the increase of lake areas. And the subsidence is more than 20-25 centimeters per year. It's very, very high fractal change of permafrost affected soils. Next, please. So this is the general scheme of stages of ice wedge permafrost degradation. I just can stress that it is ice wedge. That means that we, in this case, we deal with the permafrost with a very high content of ice. In this case, there are some stages with interesting and Yakutian terms. The first is Bylar, then Diodia, and Tympi. Just the last one is much easier. It is Alas, and this is the very important element of agriculture in permafrost affected regions. Next, please. But sometimes climate warming, together with other factors, with erosion, leads to catastrophic mega features in permafrost affected areas and used by climate change. So at the left side, we can see the thermocrust crater in Sakha-Yakutia. It grows every year, and now have more than 1 kilometer in diameter. And absolutely new feature for permafrost affected areas is craters of so-called cryovolcanism. Of course, there are no pure volcanism, but it is just methane blows, especially in Yamal territories in northern West Siberia, and you can see it's absolutely inhabited territory, and nobody saw just these processes, but now we can see several craters of this very interesting and strong process. Next, please. So this is the general scheme, also how permafrost thawing effect on climate. I will not stop very much because I think Stefan will talk about this. But I should say that now it's a lot of unknown things in these processes. Second one, please. And there are a lot of different evaluations of carbon stores in permafrost affected soils. And I'm still sure that today the soil science is not ready to supply specialists with certain and reliable data for relevant quantity modeling of carbon cycle, at least for remote areas. These evaluations are very rough, and a lot of contradictions just take place in this process. Next one. If we can just list the main types of disturbance of dry soils and changing climate. So next, and we shall focus, next please. And we shall focus on forest and tundra fires and agriculture. Next please. So fires in forest, tundra and open woodlands are very serious and important processes, and mainly it is also caused by climate change with a general drying of the territory, and I mean permafrost affected areas, and also existence and appearance of extreme seasons, extreme summers, very dry and very hot, in such northern places as Alaska and Vorkuta and Yakutia. So next, please. So there are just some graphs showing the dynamics of forest fires in the northeast of Kolyma lowland. It's also Yakutia. And I should say that this year we have an absolutely catastrophic situation with forest fires in Yakutia, and the total area of burnt forest is close to 9 million of hectares. So it's about 1/3 of Poland territory. Next, please. So what happens in the territory with the balanced with haploid turbic cryosols? Then next, please, with open large forest. And after burning, just the permafrost gone much deeper, and cryosols transformed to gelic clayosols, so glacials with permafrost between 1 and 2 meters, and then again to gley cryosols, because after restoring of vegetation, the permafrost going upward is going upward. Next, please. So then again, the consequences of fire is activation of cryoturbation, and so it goes to turbic cryosols. And in case of dense large forest, about 60 years after fire, there could be haploid cryosols. As please, next one. So this graph show the dynamics of active layer, and we could see that this is just reversible process, and the depth of permafrost is occur at the same point it was about 200 years ago, just before forest fire. And also the right graph shows their development of profile disturbance caused by cryoturbation. You can see that forest fires also lead to this kind of disturbance. Next one. Next one, please. So now we are going to agriculture change and its consequences for soils. So the upper curve shows the general trend of abandoning of agriculture. It is just have mostly economic reason. And so in developed countries do not need any more such vast, such giant areas of agriculture for getting enough harvests. But at the same time, if we look dynamics of arable lands in Alaska and in Norway, we can see that in Alaska it's still we can see the still growth and some stabilization in Norway. Next, please. Next. So now just a lot of literature and a lot of material showing that climate change is very positive a positive factor for farming in Alaska, even in permafrost affected regions. So for 5 years, from 2012 to 2017, the number of farms increased by 30%, while total US farms dropped by more than 3%. No, I think the most reason for that is just that people, local people, are very patriotic for their, especially in Alaska, and so they want to buy their own food just grown in Alaska, and they are ready even to pay more just for local products. So this is just the consequences of vegetation season increase, first of all, and just a little bit decrease of winter temperature. They are not so frosty than several years ago. Next, please. So at the left side, you can see just the main areas of Alaska agriculture. The Anchorage Palmer at the Anchorage Palmers are situated in not permafrost area, so it's just alteration of permafrost and non-permafrost sites, but Fairbanks and Delta, they have mostly situated in permafrost affected areas. And contrary to other territories of northern Alaska, the Fairbanks Delta region is mostly permafrost with ice lenses. It's not just so high content of ice as, for example, in Yakutia that we have seen before. So, and just behavior of the land turning into agricultural field, just this behavior is absolutely different. Just if we have ice lenses in deep soil horizons, or if we have no ice lenses. So if we have no ice lenses, so their permafrost deepening occur. But if we have ice lenses, we can see just about the same degradation of surface as we have seen in North Yakutia because of this pillar or thermokarst mounds appearance on the surface. Next, please. Next. So the situation in central Yakutia about just the same. So beyond ice wedge polygons, we have just no problems for agriculture, and just a lot of land returned for agricultural fields. Next, please. Yes, so no permafrost-induced problems for agriculture. Next, please. So, but when we go back to ice wedge polygons, we can see that in this, now we can see badland, but if we dig a profile in this area, so we can see that this is former agriculture, and the plowing horizon is can be seen very well. Next, please. Next. So in this ice wedge polygons, we can see the rather abrupt deepening of active layer, the thawing depth of permafrost after involvement in arable territory. But the problem begins when the deepening of permafrost reach these ice wedges, and the territory in this case, because of development of permafrost, is becomes a badland because of development of thermokarst processes. And as for soils, we can see that these turbic cryosol with different qualifiers, yes, it was qualified by Peter Schad, and you know that he knows a lot of qualifiers. And these turbic cryosols turn into different soils because of micro-relief development, and on micro-highs it is stagnant cambisols with some erosion of surface, and on microslope, and especially in micro-low, we can see some molic solonets. These a lot of sodium and magnesium coming from thawing.
Sergey, excuse me, but we have to finish already, so you still have 1 minute, okay?
Okay. I'm very close to the end. Okay. Yeah. Next, please. So permafrost architecture, ice content structure forms, is the matrix for consequences of impact of cryosystems. Next, please. So climate change is a very noticeable phenomenon in permafrost affected regions. However, the response of geocryological system is different depending on initial temperature of permafrost, organic layer depths, and other parameters. The frontal deepening of soil profiles and the fractal one take place. The last one may be catastrophic and reach not only soil but the landscape level as well. It means these mega features. Next, please. Yes, climate-induced fires, just no comments. I have already told about this. And the last one. And agriculture is not widespread, but a strong factor of cryosol transformation. And the consequences of climate change for soil is strongly dependent of cryosystem architecture, from slight positive changes to total destroy of soil color. That's it. Next. Okay.
Thank you very much, Sergey, for your very nice talk. I am sure that the problem of the permafrost soils is very interesting and important for the discussion. You showed to us a lot of beautiful landscapes, especially also very beautiful soil profiles, so thank you for that. We have time at least for 2 short questions, and let's look into the Q&A box. So we have the question from Christiana Obehi Isaac Izoya. Does it mean that thawing permafrost has positive influence on agriculture, like in Alaska? What can you say in this field?
Yes, of course it is positive if we have no high icy permafrost. If so, The problem that if we have icy permafrost with a lot of ice content, you can see just the total destroy of soil. But in other cases, it's very good.
Okay, thank you very much for your answer. The next question comes from Tomasz Kaczmarek, and he asks, what do you think? How does thawing permafrost affect the environment in the future? What is your opinion?
It has both positive, as I already told, for Alaska, and very dangerous negative effect, especially for infrastructure. It is railroads, pipelines, and even buildings. If the building in permafrost areas is very complicated process, and just the thawing of permafrost can cause just destroyment.
Okay, thank you. And the last question from Ivan Yavadzarin. Is there any efficient way to predict the probability of wildfires event, such as Saka reported in 2021 and the Black Summer in Australia? Do you understand?
No.
What is the prediction of the wildfire event on the permafrost area? I think this is the main point of this question.
Just predictions of fire is very complicated process, because in spite of the fact that there are a lot of different linkages between fires and meteorological parameters, anyway, it is have their own internal logics for development, and as I know, it took places in absolutely inhabited areas, and that's why it's not of course only anthropogenic phenomena, but just to struggle to fight the wood forest fires in inhabited and remote areas is very difficult thing.
Okay, thank you, Sergey, once again for your presentation. Now we have to go to another speaker, so I hope that you will stay with us for the further part of the conference. So once again, thank you.
Thank you.
And now, ladies and gentlemen, I have a pleasure to announce the next presentation. It will be about the climate change effect on the greenhouse gas exchange of peat soils. And this important topic will be presented by Professor Stefan Glatzel, the head of the Department of Geography and Regional Research and the Vice Dean of the Faculty of Earth Science, Geography and Astronomy at the University of Vienna. Stefan does research in soil science and environmental science with a special focus on peatland ecosystems. He is a member in the number of the national and international societies, for instance, the European Geoscience Union, International Union of Soil Science, International Peat Society, the German Society of Myers and Peat. Moreover, he has presented the European Union at Ramsar COP13 in Dubai and is the author of the Austrian Myers Strategy and Floodplain Strategy. So please welcome my dear colleague, Professor Stefan Glatzel.
Thank you, Bartek, for the kind introduction. So I'm trying to share the screen now.
Yeah. Yes, please share the screen.
Does this work?
Yes, it's worked perfectly.
Okay, great. Yeah, thank you again for the introduction, and I'm really happy to be able to present here on World Soils Day in front of this knowledgeable audience. So. Yeah, I've been asked to talk about the climate change effects on the greenhouse gas exchange of peat soils. And you may wonder why this is an issue. So I'm going to spend a few minutes when beginning this presentation about why the greenhouse gas exchange of peat soils is particular, why it's special and why it's different from the greenhouse gas exchange of other soils. Also, I'm going to talk about the tight connection between peat soils and climate, and peat soils and a changing climate. This connection is tighter than in other soils. So I'm going to also talk about what we know and what we don't know. Of course, this can by no means be comprehensive in a 20-minute presentation, but some flashlights on issues that we do know and issues that we don't know. And of course, this is also a peat soil management issue, which I'm going to spend a few slides on talking at the end of my presentation. So why is the greenhouse gas exchange of peat soils particular? Well, because let's start when we want to solve this question by looking at the involved greenhouse gases. So we're talking about methane, carbon dioxide, and nitrous oxide. So carbon dioxide, I mean, this is one of the basic the equations of life. Maybe the most basic equation of life is the assimilation and the dissimilation of carbon into ecosystems, the production of biomass, which can be summed up as C6H12O6. This is more or less what living matter consists of. And of course, I mean, this is a huge turnover that is being done by the world's ecosystems every year. And of course, this biomass is being respired again, turned into CO2. So this is one of the big equations of life. Methanogenesis is another big producer of greenhouse gases, and there are a couple of pathways, the two most important pathways. One is the acetogenic pathway, where acetic acid, CH3COOH, is being transferred into carbon dioxide and methane. And the other one is the hydrogenotrophic pathway, where hydrogen and CO2 are the sources for methane. With nitrous oxide, the equations are a little more difficult because it's a couple of processes that are involved actually producing N2O. So it's denitrification and nitrification. So it's the pathway of ammonia being oxidized. And then it's also a pathway of the reduction. So this means that since nitrous oxide is an intermediate step in these reactions, that a drying soil as well as a wetting soil can produce N2O. So N2O is an intermediate product in these nitrogen transformations. So we need to look for situations where the redox potential in the soil changes. And these are the situations where nitrous oxide is going to be released. Yeah, and so what's so particular about peat soils here? I mean, these equations and these processes in principle occur in all soils, yes, but 1 square meter of peat soil, just down to 1 meter, has something like 100 kilograms of carbon, 5 kilograms of nitrogen. I mean, these are like average values. In some peat soils, of course, this can be more or less. But peat soils have a tremendous potential for releasing greenhouse gases. This organic matter is the precursor of methane, of CO2, of nitrous oxide. So this sets peat soils apart as potentially extreme sources of greenhouse gases, and this is the case. Peat soils worldwide, and of course these are drained peat soils, release 0.5 gigatons of carbon per year. This is something like 5% of the worldwide greenhouse gas release. So there are years where this is much worse, and these are especially El Nino years, when the situation in Southeast Asia is especially dry. And So climate and climate change will influence the greenhouse gas release very strongly. Peat can only form in case of a positive local water balance. So if you look at this very simple local water balance, so we need to look at precipitation, at the surface inflow, at the groundwater inflow, but also how does the water leave the system, which is evapotranspiration, groundwater outflow, and surface outflow. So if any of these parameters change, like evapotranspiration or precipitation, for example, the conditions for the formation of peat soils will change. So climate change may impede the conditions for the emergence of peat soils, but they may also, if climate change proceeds in a certain way, create conditions for the formation of new peat soils where they have not existed before. So if we look at nitrous oxide, the left part of the graph shows us the parameters that will influence evapotranspiration. Wind, solar radiation, temperature, humidity. I mean, these are the main parameters of climate, of a changing climate. So wind is going to change, temperature is going to change, humidity is going to change, and this is going to change the net flux of nitrogen gases. So at about approximately 70% of water-filled pore space, we have a maximum of nitrous oxide release from soils. So a fully wet peat soil will not be a large source for N2O. Neither is a fully dry peat soil. But at a peat soil, as I said, like 75% water-filled pore space will potentially produce a lot of of N2O. And that's the lower part of the graph. This is the famous hole in the pipe model by Eric Davidson. We can see that the amount of nitrogen passing a system also controls the nitrous oxide release, which means the stronger the nitrogen transformations are, the stronger the N2O release is going to be. So a peat soil fertilized with nitrogen is going to be potentially a very high N2O source, but you don't even need nitrogen fertilization. Or alone the mineralization of organic matter will not just produce CO2, but it's also going to produce ammonia, of course, which is a precursor to N2O. The same is true for the carbon part of the equation. This is a sort of a biochemical depiction of what we are seeing. So on the right side, we have the anaerobic processes that we get in peat soils, in case they're wet. The left part is the aerobic part of the processes. And so a changing climate will switch the basic biochemical reactions in a soil between the aerobic and the anaerobic processes that we are seeing. So either in case of it's dry, a peat soil is going to be producing a lot of CO2, or in case it's wet, it will be producing also some CO2, but much less. But it will be producing methane, which is a stronger greenhouse gas than CO2. So this is a nice study by Swindles and co-workers. Also, a couple of colleagues from Poland were involved in the study here about the changing climate on a large scale. So this is about the last 200 and all of the last 1,000 years, this paper. And how this changing climate influences the water table of peat soils. And of course, the water table, as we have seen, is a main driver for the greenhouse gas budget of a peat soil. In case the water table is low, it's going to be producing a lot of CO2. If it's high, it's going to be storing CO2, but producing methane. So we are seeing on the top left graph, the precipitation signal in the last 200 years. No, that's the last 100 years. That's between the mid 18th century and the mid.
Sorry, we have some problem with connection with you, Stefan. We cannot hear you. And
Precipitation.
Okay, you are back. We have some internet connection problem. I don't know if it is our fault or your.
The signal is, This
Okay,
is,
now you are back. You are back right now.
oh, fortunately, thank you. I know I was, the signal was weak. I'm sorry.
So
Are we
maybe
not
you
back
can turn off your view. Only show your presentation without your
Oh,
box.
okay, I'm gonna
It will be
share
better.
again. Okay, does it work?
Yeah,
Fortunately,
it's
I'm sorry, there was a
no
problem. Yeah.
problem.
Good. So in terms of temperature, we are seeing the farther northeast we go, the stronger the warming signal gets, and this is what Sergey just talked about, right? But definitely in Poland, for example, it's getting warmer. And how does this translate into water table changes? There is no clear signal. In Poland, there are places where the water table is going down, and there are places where the water table is going up. Europe-wide, the signal is clearer. The water table in peatlands, and we are talking natural peatlands here in Europe, has been going down for the last 200 or 300 years. So the water table is going down, it's getting drier. This is probably mainly due to the rising temperature. This is a study that we have been doing in the Alps. And we are seeing here a wet and a dry year. If you go to the bottom left, you see the water table in the Pirkschachen Moor where we've been working. Where we can see that in a dry year, the water table is low, in a wet year, the water table is high. And the ecosystem respiration in a dry year is much higher than in a low year. So more CO2 is produced. This is to some degree compensated by a higher GPP, a higher gross photosynthesis in a dry year. The plants are growing better, but we need to acknowledge that the plants that are growing are not necessarily peat-forming plants. So when a bog dries out, you get more production, but not production of peat mosses. So this translates into a CO2 flux in a dry year of a storage of 25 grams, in a wet year, a storage of 80 grams. In terms of methane, there's not a big difference. So we are losing carbon in a dry year, and we are preserving, or we are not losing carbon, but we are not storing as much carbon in a dry year, and we are storing much more carbon in a wet year. In terms of methane, this may not be so clear. This is a study from Liu et al., a modeling study on the nitrous oxide release and climate change. There's a lot of data in here, and we are seeing that for nitrous oxide, the modeling is very difficult. But what we are definitely seeing, a lower groundwater table, a drier peatland is going to release more N2O. So there is a feedback between the drying out of a peatland and the N2O release. On the map for Europe, we are seeing that most peatlands in Europe, in the temperate part of Europe, in Poland, for example, have become sources for N2O. This is also a nice study by Seurich et al., who have been incubating samples of bog and fen peat from a subsoil and from a topsoil, as well as peat sand mixtures. And the peat they've been working with was earthified peat. So this was peat from agricultural peatlands. So what we are seeing here is that for CO2, there is an optimum function. So a fully wet peatland is not going to release too much CO2. It will release CO2 at about a water-filled pore space ratio of 80%. But then if the peat gets drier than 80%, the CO2 release is going to go down again. So this is an optimum function. And we are also seeing this optimum function for the topsoil of fen peat in terms of N2O release. So again, this is this intermediate pore space that I showed you before, like this critical pore space of about 80% a water-filled pore space. Once we are on the dry side of this, we are getting a less N2O release. This function cannot be seen in subsoil peat, in fen subsoil peat, obviously because subsoils are, I think, simply wetter than than topsoils, and they are usually not involved in the N2O release as strongly as the topsoils. This is from a Thiemeyer et al. Study I've been part of, a very recent one, which shows a very clear relationship between the CO2 release from peatlands and the water table. So the deeper down the water table is, the more CO2 is going to be released by a peatland. And this function seems to stop at about 50 centimeters drainage depth. So once we're at 50 centimeters drainage depth, there is no further increase of CO2 release with a further increase of drainage. Of course, for methane, this is a much easier function. Methane release really starts to kick off at about a water table depth of -10 centimeters. And these aggregate functions of the CO2 release, the N2O release, and the methane release from peat soils, depending on the water level, are shown on this graph. So there we have a pretty linear connection between the CO2 release from peat soils and the drainage depth. We have an exponential curve once the water table is rising towards a lake. So don't flood the peatland, otherwise you're going to get a lot of methane. And there is a small hump of nitrous oxide, which occurs at about 50 centimeters drainage depth. So in case we are aiming at minimizing the greenhouse gas exchange from peat soils, we should aim at a water table very close to the surface. Yeah, so what do we not know? I mean, this is a kind of flashlights, what we do know, what we do not know. We do not know, for example, which peatlands, which natural peatlands will continue to store carbon. This, I mean, basically what Sergei said. In the north, in the remote places, our knowledge is very patchy. Also, is climate change in terms of the greenhouse gas exchange of peatlands more like a disturbance or more like a permanent destabilization? I guess this also depends on how climate change will continue. But I'm inclined to see it as a permanent destabilization. And also, I mean, there may be areas where new peat soils emerge. This may be happening in the areas that Sergei described. So this is also something we don't know. What we also don't know is how the future of agriculture on peat soils is going to develop under climate change. Some areas that are covered by natural peatlands may be transformed into agricultural peatlands due to socio-economic pressures. And this should influence greenhouse gas emissions. As the pressure on natural peat soils under climate change will probably rise in some regions of the world. So this, of course, faces us with management challenges. I would say in the rich part of the world, and also in the not so rich part, we should be aiming at implementing in agriculture on peat soils without drainage, that we call paludicultures. So when we do agriculture on peatlands with a lower water table, we raise the greenhouse gas emissions. And we are talking about 5% of global greenhouse gas emissions. So this is not a small number. So if you want to tackle these greenhouse gas emissions, we need to implement in agriculture with a high water table. And worldwide, there are ongoing activities how to implement agriculture with a higher water table. And we need to worry in places where droughts are becoming more frequent about maybe keeping the water in the peat soils. There are some places where agriculture is conducted on peat, where the peat is actually where we don't have enough water. So maybe we should be worrying about keeping the water in the peatlands instead of getting them out for the sake of agriculture. And of course, we need to reassess the options of peatland restoration. Climate change is challenging our ideas of where peatlands can be restored and where they cannot be restored. So this requires a reassessment of the options of peatland restoration. Yeah, so thank you for your attention. In case you have questions, contact me now or write me an email. Thank you.
Thank you so much, Stefan. Thank you for this nice introduction. It is a very important topic. Yeah, the GHG emission from peatland, it is nowadays a very important topic. So I hope that we'll have a lot of questions to you. So let's see the Q&A box. Can you open the Q&A? Okay, we have one question. The first one is from Piotr Gajewski. It is widely known that water-logged peatlands emit higher amount of methane. In this case, is the paludiculture a real environmental friendly method for peatland management? Please, what is your opinion, Stefan?
Yeah,
Very good.
there is an issue of methane release with paludicultures, definitely. So it has been shown. I mean, we've seen these basic functions. When once the water table is very close to the surface, we'll get a rapid rise in methane. Also, depending on which plants we cultivate, we get an aerochematic release of methane via the plant tissues. So in case we implement paludicultures for the sake of the climate, we require an honest appraisal of the rising methane emissions. But the experiments on paludiculture that have been going on so far have shown that the CO2 emissions, that the avoided CO2 emissions overcompensate the rising methane emissions in most cases. What we really need to watch out for is when we flood previously drained peatlands and create shallow lakes. These shallow lakes are going to be big methane sources, and these are not conditions that will decrease the greenhouse gas release. So this requires management challenges, yes.
So thank you for the answer on this question. And we have another one from Iman Yavadzarin from Iran. Thanks, Professor, for a nice talk. How can we monitor GHG emission from peatland in large scales over time? Can we trust to remote sensing or just should focus on laboratory methods?
Yeah.
Especially field method in this case, I think. Yeah.
Well, I guess we need a combination, right, of the methods that you mentioned. Remote sensing techniques are getting better from year to year. So I know of airplane-based systems that can monitor the greenhouse gas concentration on top of peat soils. This should, in theory, also be possible from satellites, but I know of no working system that actually remote senses the methane and CO2 and nitrous oxide concentration on peatlands from satellites so far. But technically, with laser techniques, this should be possible. But of course, this is the future. For now, airplane-based systems work. Drone-based systems may be a good option for the medium scale. But if we want to upscale today, we need a combination of chamber measurements, of eddy covariance measurements on site, of laboratory experiments, and of upscaling procedures involving proxies. And these proxies are mainly surface cover and possibly groundwater table, which should be able to sense remotely with radar techniques. So this is a rapidly emerging field.
Okay, thank you. And another question from Christiana Obey Isagizoya, one of my students. Thank you for your lecture. Dr. Glina, keep talking about restoration. Same with you. Practically, are there policy in place to stop degradation? Why are they not implemented? What are the limitations?
For restoration.
Yeah, about restoration.
Yeah. Okay. It's easy. It's relatively easy to restore abandoned peatlands or peatlands that have lost some qualities of a natural peatland due to a lower water table. So the main problem here is in some places the water is not there anymore due to climate change. So in some places where a peatland has formed over the entire Holocene under a different climate, the water may simply not be here anymore. That's a challenge. In most cases, however, it's not the climate, but it's the drainage of systems bordering the peatland we want to restore. Especially when the terrain is flat, like in many places in Poland. And some peatlands are drained for agriculture. It is quite hard to maintain a high water table in a natural peatland that we want to restore. So there we need a buffer. We need a buffer. We need to know the hydraulic conductivity of the peat, and we need to take care that the water stays and remains in the natural peatland, but the water table remains at a level in the surrounding agricultural land, but agriculture is still possible. So this is a technical issue, and it requires a buffer between the peatland and the agricultural area.
Thank you. And we have one more question, but this time from the chat box from Juliette Ogbona. She asking, what are the methods of controlling this peat eradication? I think degradation, but you already mentioned what we can do to stop the peat degradation, but you can also answer on it.
Yeah, well, I mean, close the ditches, right? Get the water back in. That's the most important issue. But of course, if you close the ditches, you in many cases you will encounter conflicts with agriculture. So this is why we need the buffer.
Yeah. Okay, and one question from Christiana. Please talk more about the policy related to the restoration, I think she mentioned. Maybe you can mention something about the European Union legislation in this case.
Okay, the legislation.
Yeah, she wants more info about the.
Okay. So I'm very much into the Austrian situation here, and but this probably applies for many EU countries. One issue is that we have several levels, depending on which country you're in, of the responsibility. The countries that I know well, like Germany and Austria, have legislation where conservation laws are made in the federal states. So the government in Vienna or in Berlin doesn't have a big say here. It's the federal states that have a say. So this the legislation may be different on a very regional level. Then another problem is that there is a European legislation which is not followed by some countries simply. For example, Austria doesn't always follow what the European legislation says, and this may be true in other countries as well. So I think a main issue here is a lack of coordination and a lack of compliance to the different levels of legislation that exist. So I think, and this is what Ramsar is fighting for example, that we need a simpler legislation that makes the implementation of peatland protection measures more attractive. And probably this is also going to touch agricultural subsidies. Yeah. What does the EU want to subsidize in agriculture?
Yeah, thank you so much, Stefan. Okay, we are on time, so I hope that all of people who are asking the question are satisfied with your answers. So once again, thank you very much for your contribution to our conference, and please stay with us as long as you can, because I know that you have to go for a next lecture today. So it was nice to see you and to hear your talk. Thank you once more. Bye. Okay, so now we can go to another presentation, the presentation number 4, entitled Soil Water Retention and Agriculture Drought in Relation to Climate Change, a Case Study of Poland. This presentation was prepared by Dr. Jan Jadczysyn and Dr. Andrzej Doroszewski from the Institute of Soil Science and Plant Cultivation, State Research Institute in Puławy, but the presentation here will be given by Dr. Jan Jadczysyn, the researcher at the Department of Soil Science, Erosion and Land Protection at the mentioned institute. His scientific research includes the assessment of soil conditions for agriculture development. he is a co-author of very important thing, for instance, the development and implementation of the agriculture drought monitoring system, ADMS, in Poland. He was responsible for a part related to soil moisture monitoring and assessment of the impact of water stress on plant development. So please welcome Dr. Jan Jadczysyn.
Thank you. Thank you for my introduction. So let me present the lecture.
Please share your screen.
Okay.
Okay. Okay, we do not see the full screen. Okay, now we, no, it's not good because we also see some notes by you.
Okay.
So, okay, maybe we can display your presentation, okay? And you will only point it when we have to switch the slide. Yeah?
Now it's okay?
Oh, now it's okay, perfect.
Oh, okay.
Yeah.
So thank you for introduction, and of course I want to present the lecture on my own behalf and Professor Andrzej Doroszewski and our team dealing with agricultural drought monitoring system in our institute. So Poland, like many other countries in Europe and the world, has been affected in recent years by water storage, water deficiency in agriculture, and increased frequency of drought. So this problem are related to climate changes and increasing temperature, now mainly increasing the temperature, which lead to increase in evaporation and transpiration, which reduce the water resources in soil for plants. The next, low and irregular distribution of precipitation during the growing season, like what was mentioned before during this first presentation. And the next, the limited water retention of sandy soils resulting from the natural structure and soil texture group. So in Poland, the sandy soils share a lot of areas, and it's the main problem with retention, water retention in our soils. The next, so the compaction of the subsoil, excessive drying of the top layer of soil as a result of agrotechnical measures. And in Poland, in the last decades, there has been a systematic increase in yields, which is associated with higher water consumption. In Poland, so we have problem with water deficiency in the large area, mainly in the middle part of Poland, where the climatic water balance for many years during the growing season is less than 200 millimeters, and some area less than below 220 millimeters. So this problem with water deficiency, it's a regular problem now in Poland. And the areas of natural water deficiency in Poland as a result of deforestation and drainage since the middle 19th century. So the many deforestation area and drainage system was developed. So and now we see the deficiency, surface water deficiency of surface water in a large area. And In this area, with water deficiency, we can see the intensification of MAC processes and a lot of the peat soil, organic soil, are reduction now during the MAC processing. And the result of this is the higher frequency of agricultural droughts in Poland, in this area. So we can see in the right map the frequency of agricultural droughts in the period 2007 and 2018, and the frequency is 10, and some communities in 8, 9, and up to 10. So it means that almost every year, so we can have agriculture the droughts, and it is a big problem for our farmers. And there is the reason, so we can start to develop the special agriculture drought monitoring system in Poland. The system was developed in our institute, and World Meteorological Organization recommends 3 indicators for monitoring agricultural drought. It consists from climate, soil, and crops. And our drought monitoring system consists of 3 components. The first is the current value of climatic water balance. The second is the map of soil categories of susceptibility to drought based on available water. And the third is the critical values of climatic water balance for individual species and groups of plants. So now, so a few words about the components of climate. Climate components, it's climatic water balance, calculating according to Penman-Górski formula. It's a reason between precipitation P and evapotranspiration. And to calculate this value of climatic water balance, so we input several indicators, weather indicators, the average air temperature, insolation, relative humidity, average wind speed, and the length of the day. So based on this indicator, so we calculate the climatic water balance for every decade, every 10 days. And to calculate the climatic water balance, we use more than 7,700 weather stations and measuring points in Poland. And the next component is the soil and soil water retention, which depends on soil texture, especially clay and silt content fraction. It depends on humus content, which retains 3 to 5 times more water in relation to its mass. It depends on soil structure, microorganisms, and soil pH. So these components are very, very important for water retention. And indicators characterizing the water properties of soil is the field water capacity, permanent wilting point, and available soil water. So in our drought monitoring system, we use the available water storage to develop the map of categories of soil accessibility. And now, so I want to present the influence of soil texture on its water properties. It means in increasing clay content, the water content is increasing. So the water content means field capacity, water, available water, permanent waiting point. It's in the soil increases with increasing the clay fraction. And available water for the soil texture group was the basis for determination the categories of soil susceptibility to drought. So we determined 4 categories. First category, category 1 for very loose sand and sand soil, which available water from 92 to 170 millimeter. And the next category 2, it's characterized by available water from 138 to 155 millimeter, and so on. And category 4, it's the category not very susceptible for to drought. And based on this categories, so we developed the map of categories of soil susceptibility to drought for Poland. So we can see this map, and the first category, very susceptible soil, share about 21% in Poland. The second category, susceptible, share about 36%, and the next, third category, moderately susceptible to drought, share about 24%. So it means the more than 50%, exactly 57% in Poland, we have sand susceptible to drought, susceptible soil to drought. And the third components, the crops. For the crops, we have developed the critical climatic water balance value for plants, in particular reporting periods. For we can see the only the 3 plants, but we developed this critical climatic water balance values for 14 plants monitoring in Poland, and this critical value is related to soil category from 1 to 4, and is different for different reporting periods. It's changing along the vegetation season. According to the Act of Insurance of Agricultural Crops and Livestock in Poland, so agricultural drought means yield losses caused by the occurrence in any 60-day period from March 21 to September 30 of a decline in the climatic water balance below the critical value specified for individual species of crops and soil. And now we combine the three components, the weather, soil, and crops. We transfer the meteorological data to our server. So we develop the precipitation map and a map of other meteorological indicators, as I mentioned before. And then we calculate the value of climatic water balance. It used, which I mentioned before, so we use more than 700 meteorological stations and measuring points. And then we analyze the soil, the categories of soil susceptibility to drought, and compare the critical value of climatic water balance and the categories of soil susceptibility to drought. And we developed the drought risk maps for all crops monitoring in Poland, the 14 crops. This is the map of the drought risk maps for crops. And based on this map, we calculate we present the tabular data on crop risks for each community in Poland, where we read the crop risks for different crops. And this system, this data, this information are used by farmers, insurance company, Ministry of Agriculture, public organization. And there is an example where the climatic water balance for the period from May 1st in 1219 to 30 June for one decade, but calculating this value from the 60 decades before. And the right map is the extent of drought for spring cereals in the same period. So in this map, so we can read the drought criteria, the share of agricultural land at risk of drought. It's for all the crops we present this share of agricultural land risk of drought. And the example of detailed description of the drought risk for the one community Kłodawa. In this table, we can read the risks of drought for many crops in different period of vegetation season. As a part of the agriculture drought monitoring system, we implement the soil moisture monitoring system as an element of the verification of the drought risk assessment. Soil monitoring measure system is implemented throughout the country in 20 reference farms and 68 production fields, and involves the following activities. The current assessment of plant vigor, measurement of soil profile moisture at 6 depths, 10, 20, 30, 40, 60, and 10 centimeter deep, analysis of agrotechnical operations, and yield evaluation. On each farm, so the automatic weather station are installed, so we can analyze the weather, the precipitation, temperature, and the other other factors. Assessment of plant development and soil moisture measurements are carried out systematically twice a week during the growing season from March 20 to October 31. Soil moisture in there is an example of soil moisture in the profile measured the 1 point C in the reference farm in Baborówko in 29. So we can see the soil moisture in different depths, from 10 to centimeters to 1 meter, and the precipitation and the temperature in this line. So we can analyze all factors which have influenced on the water risk. Recommendation for increasing water retention and water use efficiency in agriculture and environment. First, the construction of retention reservoirs, restoration of wetlands and ponds. The second, use of reduced till and no-till, no-plowing soil cultivation system, which reduce the evaporation. The third, technical and organizational improvement of existing drainage system for dual purpose drainage and irrigation. The fourth, the adaptation of land use structure to risk of surface runoff and water erosion. The fifth, it's the adaptation of the design farm roads and plots in land management and land consolidation to the topography in order to applying agrotechnical measures in accordance with the direction of contour lines. And the use of modern irrigation system based on the current value of water available to plants and forecast rainfall. Thank you for your attention. It's all. Thank you very much.
Thank you very much. Thank you very much, Dr. Jabczyszyk, for this nice presentation. In my opinion, the presented topic is very important in the context of ongoing climate change, especially, as it is sharpened drought in many parts of the world, not only here in Europe, we have the situation. That's why it's increasing its frequency, severity, and duration. So I hope that you will have some questions. Let's look in the Q&A section. We have 2 questions, but before we go to this question, I would like to ask my own, if you allow. So what was the level of yield losses adopted to determine the risk occurrence of drought in the agricultural drought monitoring system in Poland? If you can answer on it.
Yes, thank you for this question. The yield losses means reduction of the yield by 20% due to drought in the commune area in a given year in relation to the yield obtained in the average long-term weather conditions. So the risk means the lose the yield about more than 20%.
Mm-hmm. Okay, thank you.
So then we can mark this risk of the drought for different crops.
Okay, thank you for this explanation. So now some question from the Q&A box. So the question from Iman Yavadzarin. How often and how are the ADMS and SMMS database updated technically? And how do you survey the accuracy of created continuous maps by ADMS framework for the total area of Poland over the time? Thank you. Very complex question.
Very complex. So we use the weather data for each decade and analyze this weather data 6 decades, 60 days before, and then we calculate the climatic water balance and compare this value for the critical value for different crops in different period of vegetation. And we take the weather data automatically, so by GMS system. So this data is recorded in our server, and some data we take from the Institute Meteorology and Water Development. So for our area in Poland, so we use more than 700 weather station and measuring point of precipitation data.
Okay, so thank you very much for the explanation. We still have 2 questions, but unfortunately we do not have more time for it. So to those people who are asking, please send this question by email directly to the speaker. Yes. So once again, Dr. Jachyszyn, thank you for your nice presentation and for your contribution to the conference. And
Thank you.
I hope that you will stay with us. Ladies and gentlemen, now we have to go to our 5th presentation for today. The next 2 authors, Professor Paweł Rutkowski and Dr. Monika Konatowska, will take us to the forest this time. So we'll take closer to the forest soils, and they will describe the effect of climate change and forest management on soils. The presentation will be given by Professor Paweł Rutkowski from the Department of Botany and Forest Habitats from the Poznań University of Life Sciences. He is a specialist in forest habitats, soil science, forest plant communities, and Nature 2000 network. Moreover, Professor Rutkowski is member of the Scientific Council of the Słowiński National Park and the Drawieński National Park. And since the year 2021, he is a chairman of the Regional Council for Nature Conservation at the Regional Directorate for Environmental Protection in Poznań. So a lot of functions, a lot of membership. So please welcome Professor Paweł Rutkowski.
Thank you very much. Do you hear me?
Yes, very well.
Okay.
But unfortunately, we do not see the full screen, only the work mode.
Oh, no.
Yes.
Maybe now?
Not now. So I have a solution. Maybe we will display the presentation.
Okay, so I will try once again, okay?
So please only stop share your screen and we will display your presentation, okay?
Okay.
Great. Okay, now we have the full screen and you can start. Thank you.
Okay, you see the full screen, but I can not change my
yes,
slides.
We will change it, but you have to point it when, okay?
Okay. Welcome to everyone, and thank you very much for your kind introduction me, dear Bartek, and thank you very much for inviting me to the presentation. I would like to add that I am mainly the forester, not soil scientist, but I am a member of Polish Soil Society, so I have the great pleasure to be a member of this meeting. I think that my topic, the impact of climate, mine and my colleague Monika Konatowska from my department, the impact of climate change and forest management of soils, forest soils is very important. So next, please. but you see the slide, but I don't see my slides. Okay. Why this topic is important? Because Poland's forest cover amounting to 30.8% is similar to average forest cover of the world. And our forest cover is also close to forest cover in Europe, excluding Russia, of course, and it's far lower than the forest cover of South America, Europe, including Russia and Southern America. But Poland's cover is, however, much higher than the forest cover like in Africa and Asia, in example. The main Polish forest type is rusty soil. And you can see on the picture from the right the distribution of rusty soils in Poland divided into 3 subtypes. The mainly subtype of rusty soils in Poland is podzolic rusty soil. And from the left, you can see the distribution of main forest complexes. And when we compare the distribution of rusty soils and forest complexes, the correlation between the rusty soils and forests is, I think, that good visible. Another one important topic of our forestry and soils is a great amount of rusty soils and forest on post-arable sites, especially in the typical rusty soil. Where the post-arable soils are about 43.4%. So it's a very high level of arable sites under the forest. So it have consequences because the forest soils, especially under our native species, differ from soils of other land use system. Especially is the upper horizon of soils where we have the arable lands, the layer after plowing is very, very good visible. Sometimes in rusty soils it's visible up to the 200 years. We have good documentation about and examples where we have the second generation of forests on arable sites, so we can count the forest was planted about 200 years ago, and during all the time the arable layer is still visible. Under the forest, soil is untouched and quite different. According to the major scientist, Jelibo, there are 4 major soil formation factors like parent material, climate and living organisms, and topography. I would like to add another one important factor, the time, of course. And the time is important, and on the picture you can see the changes in Słowinski National Park where the dune sands go on the peat box in the rate about 5 meters per year, so it's a very, very fast change of climate of soil conditions. Obviously, climate effects is important and effects on forests and thus on forest soils. But forests affect on climate too, and the impact of forests on climate depends on forest management. You can ask how can we affect on climate but forest management? We can affect by regulation tree species composition according to the site conditions. And as our unpublished studies show, the differences between different types of forest are great. We compared to 2 types of forest, pine with Pinus sylvestris, the main Polish tree species, and beech, Fagus sylvatica. And the differences in the temperature and humidity humidity 10 centimeter above the ground level is very high and good visible. Under the pine forest, the maximum temperature was noted in the year 2016, 41.8 degrees of centigrade, but under the beech forest, only 29.3 degrees of centigrade. But the minimum air humidity was noted under the pine forest 23% and 49% under the beech forest. The research plots are situated.
Paweł,
yes.
sorry that I interrupt you. Can you indicate when to change the slide, because you do not say it before? Is it okay right now? The slide which is displayed right now is okay?
Yes.
Okay, so please only indicate it when we have to change the slides, okay?
Okay. Okay. But on which slide? Where are you on my slides? On which slide?
Do you see the slides or not?
I see this, my slides, but I'm not sure if the slides I see is mine or from your computer.
No. You have to watch the stream on Zoom right now.
Okay. So you should see the slide with once again with the Słowiński National Park and
Okay, so we are not seeing this.
You don't see it?
No.
Okay.
Okay, now we see. Now we see the Słowiński National Park. And
Okay.
please, every time you switch the slide, indicate it, okay? Then we will switch it.
Okay. So maybe we'll back to the slide number 3, where you can see the distribution of rusty soils and forest complexes in Poland.
Okay, the first slide. More. Okay, here. Yes, now we have it.
Okay, because I'm not sure, do you have see the slide or not?
No, now we have the slide with the distribution of the rusty soil. It's okay.
Okay, so the next slide is the share of arable sites in the rusty soils in Poland. So please change to the slide number 4.
Okay. You see it or not?
Okay. So next, please.
Now we have 2 soil profiles.
Okay, and I said that there's a great difference between the upper layer of the soil under the forest and in the forest with the arable history. From the right, we can see the arable rusty soil. From the left, the typical brown rusty soil under the oak forest. So next, please. And here you can see the part of Słowiński National Park where the sand of dunes goes on the peat bog on the right, and it is with a speed about 5 meters per year. So next, please. Okay, and here you can see our research plot in the Słowiński National Park, where we compare the differences between the soils and between the climate of the forest under the pine and beech forest. And I said that differences are as on the picture. 41.8 degrees of centigrade, the maximum temperature under the pine forest, and 29.3 under the beech forest, and the minimum air humidity 23% under the beech, under the pine forest, and 49% under the beech forest. So next slide, please. And you can see the map of our research plot, and these 2 plots with the differences of climatic conditions are in the distance of 1.6 kilometers each other. And from the left, in the top, in the left, you can see the research plot under the pine forest. with a typical soil for Słowiński National Park, and from the right, the similar soil, because it is a soil composed of dune sands, but the podsolization process is much more visible. Maybe it is connected with much more humidity under the forest. I think that the topic important to the investigation. So next, please. But our forest plantations, because in Poland we have much more plantations. We have not a primary forest. So forest plantations are often subject to relatively frequent and severe soil disturbance from intensive harvesting and site preparation practices. This disturbed soil system may be more vulnerable to the climate change, but they may also offer more opportunities to manage such impacts as part of forest management. These opportunities will be location specific and determined by interaction between climate and terrain and vegetation and soil type and the degree of management intervention. But the disturbance are really very intensive. So you can see an example of one of our forest complexes, the big forest complex in the western part of Poland, when this white rectangles are the clear cuttings visible on the satellite photo. And you can ask why it is so often used in the Polish forestry. Maybe next slide, please. It depends on the Polish forest management, and it depends on our main tree species, which is the pine, Pinus sylvestris. And typical forest management for pine forest is shown below. In the Polish forest, we cut our pine stands every few years. So you can see from the right the pine fragment of forest was 70 years old. After a few years, the forest was cut and planted. So we have here the younger pine stand about 11 years old. After next few years, another fragment of forest was cut, and here the planted pine is now 8 years old. And on the picture in the middle, you can see the clear cutting just after the stand felling. So from the left, you can see the old stand composed of pine about 117 years old. And under the pine forest, it's the second layer of the forest composed of beech 42 to 67 years old. And this part of the stand will be probably cut next year. And the situation will change completely. Next slide, please. And what happened after the cutting the forest and during to such management of forest? The temperature on the open area is of course rising. The humidity is dropping. It affects on the microorganisms in the soil, in the upper layer of the soil. And next, please, next slide, please. And finally, the plant species composition is changing, and the most planted tree species is pine, of course. But on the rusty soils, generally on the sandy soils, the pioneer plant species appear on the surface of the soil. In this example, you can see the lichens between the rows of pine forest. Next, please. So what are the differences between the forest and open area, and how it impact on the soils? Under the forest, especially under the deciduous forests, the light is diffused and shadow is all the vegetation season. Next, the temperature is lower than in open area, and in the consequences, the humidity is higher. And the most important, the soil is untouched. But after the clear cuttings, the area is open, so we have the full light. And next, the high temperature and the low humidity. In addition, the strong evaporation from the soil surface, and maybe finally the ultraviolet radiation, which impact on the microorganisms in the upper layer of the soil, of course. So next, please. And in the consequences of such management, maybe we have the differences between the subtypes of the soils, and under the deciduous forest, the most rusty soils, but under the pine forest, the most we can find the podzolic rusty soils. Maybe it depends on the forestry species, but maybe it depends on the change of climatic conditions on the open area. But maybe we can consider the both of factors. So plant species composition and the changing of climatic factors on the open area in the forest. So next please. And we must take into account the mechanical changes in the soil. From the right, you can see the pine stand planted in the rows, and the soil in the rows is changed by the preparation of the soil to the planting. Sometimes it's much more visible, sometimes it's less, like from the left on the soil. But it is a very, very high level of such ingression in the forest soils. So next, please. So conclusion, the main Polish forest soil subtype is rusty soil, and we must take into account that ecological spectrum of rusty soils is very wide, from coniferous to deciduous forest, and if it is a coniferous or deciduous forest, it depends on the forest management. There are many gaps in our knowledge how climate change will affect the forest and forest soils, but we know that we can affect on forest climate by proper forest management and tree species composition suitable to site conditions. And next, please. But we have the gaps in our knowledge, and what are the gaps? Next, please. The gaps depends on the scale of the changing of climate conditions, because we have 4 scenarios, and first scenario is that it's connected with decreasing temperature and with decreasing of precipitation. Next, when the decreasing temperature is connected with increasing of precipitation, and 2 other scenarios when the temperature is increasing and the precipitation is decreasing, and finally when temperature and precipitation are increasing. And all depends on the consequences, depends on how high the increase will be or how low the decrease will be, because when the temperature will decrease a little, so we can think about the coniferous forest, but when the decreasing will be much more, so maybe finally the ice age will coming, and of course it will change the soil totally. When the temperature will increase, it is important what happened with the precipitation. Professor Chojnicki said about the consequences of the climate changes. And I think that for the forest, it is very, very important, because water, I think, in my opinion, is the most important factor for forests and for life generally. And when the forest will get the much more precipitation with increasing of temperature, we can see the maybe favor conditions for deciduous forest. But when the precipitation will be decreasing, so it depends on the scale of decreasing. When the precipitation will be lower than 400 millimeters per year, maybe the forests disappear in Poland, because I still say about the situation of Poland forest. And below the 400 millimeters per year, maybe forest decreased and change into the savanna, but finally maybe will be the desert on soil sanity in consequences. So all depends on the scale of climatic conditions, but much more in the nearest future depends of our management of the forestry in Polish forests. So it's my final conclusion, and I would like to thank for everyone, and I'm waiting for the questions. It is a final slide. Thank you for your attention, of course, but it is a final slide because I like this photo. It is a photo from Mars, of course, made by a Curiosity rover, and maybe it is an answer what is important for forest, and not only forest, but life generally, because I suppose that soil on the Mars maybe is not bad, but the weather is nasty. So I think that the climatic conditions is the most important for forests and for all of us. So thank you for attention once again.
Thank you very much for this nice presentation, Paweł. It is also a very important topic, as every presenting today. In my opinion, the possible impact of climate change on forest soil health is an important problem, especially as the forest ecosystem act as the second largest carbon storage in our world. Yeah? So we have to pay attention and pay a special focus on this ecosystem.
Okay, as I said, the forests cover about 30% of land area, so it's very, very important ecosystem.
Yeah, of course. So I see that we already have some questions in the Q&A box. So the first one question is from Łukasz Mendyk from our department. How could the European Green Deal affect the forest management? Please take us closer to this topic.
What is
Green Deal? Maybe you can explain at the
okay, I think that you think about the European policy about the protection of biodiversity. So I saw on the Q&A box earlier that some of people asked about the policy. So I think it's very important question, because foresters talk a lot about the Green Deal, the European Green Deal, and we can take the 3 commitments by 2030 under the consideration. The first is legal protect a minimum 30% of European lands. I think it's changing nothing for Polish forestry and maybe for Poland generally, because in Poland we have the 32% of protected areas. So I think that this commitment is neutral for Polish forest. The second, it's much more important for foresters and the forest maybe, because the commitment says that strictly protect, we should strictly protect at least 30% of 30 protected areas. So it means that we should protect at least 10% of land area of each country. But the consequences of this point depends of the definition of the protected areas. because in the same point, the European law said that we should protect the old growth forest and primary forest. I suppose that there are no primary forests in Poland. Even Białowieża forest is not completely primary forest. And I suppose that in Europe, we have no primary forest too. But the second part of this point said that we should protect the old growth forest. And the consequences depends what are we thinking when we say about the old growth forest, because there is no definition in our law and European law what means the old growth forest. Someone would like to see the old growth forest as a forest older than 100 years. But in my opinion, the old forest is a forest when the age is half the maximum age of forest of given species in the country. So if in Poland the oldest oak stand is about 500 years, so the old growth forest for me is the forest more than 250 years. So it depends on the definition. Okay,
thank you so much for this answer. And still we have two questions and more or less 2 minutes more. So please give a short an answer to the next question. So the first question is from Jean Diata. What strategy will you suggest for plant cover in terms of the mean and long-term drought resilience? Deciduous or coniferous forest? Please explain. But shortly, please, okay?
Shortly, I suggest the plant trees according to the site conditions. So on the fertile soil, we should plant the deciduous forest. On poor soils, we prefer the coniferous forest.
Okay, and the last question from Ivan Yavazarin, the most active participant I see at the moment. Does advantages of local and temporary deforestation of pine trees in target sites outweigh the disadvantages, such operations from both forest management and soil degradation point of view? Very complex question.
Okay, it's a very important question because we take under consideration only the price of wood, but we start to think about the all prices when we use the forest. So we can take under the consideration the natural environmental consequences and not only the price of wood. So it is a very important question. I with great pleasure will answer on the questions by email. When someone will want to send me an email, I will answer. But I would like to add another one point that I said the main Polish soil type is rusty soil. It means that the most of forest in Poland depends on the weather condition, because generally there are no groundwater level in the rusty soils in the tree root zones. So all forest depends on the precipitation. So the weather is very conditioned, and so the climatic conditions are very important to our forest.
Okay, thank you for your answers and for your nice talk again.
Thank you.
And now we have to carry on our conference because we are 1 minute over the time. So this is not so bad, but we have to continue. So once again, thank you, Paweł, for your presentation.
Okay, thank you very much.
Participation.
Thank you very much.
Okay, ladies and gentlemen, now is the time for the 6th presentation of today. And in this case, it will be my presentation. So I'm gonna to talk about the main drivers, but we have to wait for the presentation because you do not see it. Okay. Okay, so I'm going to talk about the main drivers involved in the process responsible for the dissolved organic carbon production and further in the dissolved organic carbon export from the peatland soils, with a special focus on fen peatlands, because the fen peatlands are the most important soils under the agriculture use in Poland, in Europe. So there is now a large body of evidence that dissolved organic carbon export has increased significantly in the recent decades. especially because, of course, of the climate change, as we observe. Although there is a still very huge debate all over the world, what is the most important drivers? Yeah, because the drivers connected to this process are really interact between each other. So this is very difficult to distinguish the single one, the most important. So during this presentation, I will try to explain you the situation and the main uncertainties. So if we are going to the next slide, what happened? Oh, sorry. Yes. Okay, so maybe you can switch it. Okay. Yeah. Okay, now it's working. So if we are going further into the presentation, so as common we know, the peatlands globally covers around 400 million square kilometer all over the world, yeah, but it corresponds only to circa about 3% of the total Earth's land surface. But unless it's covered only so small part of the world, the peatland soil store 1/3 of the global soil carbon. It is given in the available literature that it can be 450 to 1,000 gigaton, depends on the sources we can find on the internet. And 1/3 of this carbon stored in peatland is located in the tropics, of which especially 60% in Southeast Asia, especially in Indonesia and Malaysia, which countries right now are suffering because of the palm oil plantation. They are suffering from the peatlands burning, which emit a lot of carbon dioxide into the atmosphere. And what is important, undrained peatlands presently sequester up to 100 megaton carbon per year. But as you can know, we have very small part of the world covered by a natural or a semi-natural peatland at the moment. So this is a really important question, an important issue to restore the peatland, what was already mentioned by Stefan Glasser in the previous presentation. So now something about the climate, what was very nice introduced by Professor Chojnicki at the beginning of our conference. So if we see the slides, we can observe that the highest anomaly in the global temperature is observed in the northern hemisphere. You can see the red color, even up to 4 or 7 degrees. If we compare the temperature from the year 2022 to the years 1951 and 1980. So what is mean for the peatland preservation? A lot of peatlands are mainly located in the northern hemisphere. Yeah, this is obvious because there we have lower temperature, high precipitation, so perfect condition for the accumulation of organic matter, of accumulation of peat. But now during the global climate change, the situation is totally different. Yeah, because now this peatland ecosystem started to be a source of carbon into the atmosphere, not anymore a sink. That's why we can say that the warming temperatures threaten to turn the world's peatlands into the massive carbon emitters. This is a very important question, very important issue. And now also we have to be aware that not only climate, unfortunately, can affect the peatland ecosystem. One of the most important factors is the human activity connected to the peatlands management. This situation is very worse. We have to be aware that ecologically intact peatlands have become a rarity in Europe, as almost 50% of the European peatlands are degraded. This is the latest data reported by FAO in 2019. In Europe, the fen peatlands are mainly used as agriculture land, as I said. That's why it was reported by Josten and Clark in 2002 that in totally 26% of the peatland area has become converted to agricultural land, including especially pastures, grasslands, and croplands. Moreover, based on the data reported by the FAO, as I mentioned before, we could find that the total area of peatlands in Europe used for agriculture is estimated to circa about 11 million of hectares, of which almost 6.4 million of hectares are using as a croplands and 4.6 million of hectares are using as a grasslands. So we have to really be focused on this ecosystem as such huge area are threatened by a human and right now also by a climate change. And now a few words about the carbon cycle in peatlands. It was already very well described by Stefan Glasser the vertical pathways. So I mean the CO2 release and the CH4 release from the peatland. So most of this graph which you see right now. But in this presentation, I want to be focused on the lateral pathways of carbon forms from peatland. So in this case, we will mainly talk about the particular organic carbon forms, dissolved inorganic carbon forms, and dissolved organic carbon forms. So these forms, which I mentioned already, they are transported from peatland, they are exported from peatlands mainly via the lateral pathway. So we can say that it is mainly with the water outcome from the peatland. So if we drain the peatland, it means that with the water, which is go out from the peatland ecosystem, also a lot of carbon can go. And again, about the carbon forms. So all of these carbon forms, which I presented in this slide, are incorporated into waterborne carbon. This term, the waterborne carbon, was implemented in the literature by a Professor Billet in 2004, and right now it is really a worldwide term related to the labile carbon forms in peatland ecosystem. So the waterborne carbon forms are important component of the overall carbon balance. It is generally accepted that the omission of the waterborne carbon fluxes might lead to underestimating carbon losses from peatlands. That is why we have to incorporate the water carbon borne into the general calculations for the carbon emission from peatland, because very often we can find situation that people only act with the greenhouse gas emissions, so carbon dioxide and the methane, and don't include the waterborne carbon forms, especially dissolved organic carbon. Because dissolved organic carbon continue the most important form, labile form of carbon we should take into account if calculating the carbon balance within the peatlands. So we can even say that dissolved organic carbon contributes to more than 80% of the aquatic carbon export from peatlands. It was stated in the article by Rosette et al. In 2019. And furthermore, very interesting report was also published by Evans et al. In 2015, and they state that the dock export from drained temperate peatlands, so in a temperate climate zone, was estimated to circa about 1.05 ton of carbon dioxide equivalent per hectare per year. So really huge amount of carbon could be exported from peatland in the form of dissolved organic carbon. A few words about the methods of dock analysis, because it is also very important if you are talking about this. Of course, mainly the dock concentration is analyzed in the water sample, especially in the pore water or the drainage water. And in this case, the authors want to show the rate of the export of the dissolved organic carbon from the peat soils. And in this case, we firstly have to distinguish what is dissolved organic carbon and what is the particular organic carbon. And for this, we have to use the filtration with using the specific pore size 0.35 micrometers. Yeah. And then we have to also make the acidification of the sample to avoid that the analyzer we use will also take the inorganic carbon. Yeah. Then filter sample, of course, should be storage. The storage part is also very important because there is a lot of information that the storage part could also affect our results. So as it was reported by Cook in 2016, the best way, of course, is to analyze the samples immediately after the filtration. But if it is impossible, they should be cold storage, not frozen, cold storage at the temperature not higher than 4 degrees Celsius, and especially in the dark. Why? Because the DOC is photochemically active. So it is known that in the light, it is totally could be the amount decrease. But if we are not able to make the analysis very shortly, immediately after the filtration, so we can apply the freeze storage, but this is only suitable for the bulk dock measurements, not for the qualitative analysis. And now to the main point. Factors controlling DOC production and losses from the fen peatland soils. So we can say that there are factors grouped into the biotic and abiotic factors. Yeah, we know that this process is controlled by several factors. That's why I decided to group it into these two groups. And based on the literature study, I have chosen the most frequently reported factors. So we can say that this is the human activity, microbial activity, and vegetation, if we are talking about the biotic factors. And in the case of abiotic factors, it will be the climate, weather conditions, temperature especially, water level, physical soil properties, and chemical soil properties. And now in the further part of the presentation, I will try to explain the role of each of the factor I mentioned here. Okay, the first factor is the human activity, mainly the land use type. In almost all cases, the peatland management involved drainage. As you know, drainage is lowering the water table, what exposing the organic matter to oxygen. And if analyzing different land use type, we can see that the DOC export are definitely higher from the cultivated peatlands if compared to the pastures or grasslands. It was proved by many studies. Some studies from Germany conducted on very highly modified peatlands prove that the DOC concentration under high intensity grassland compared to low intensity grassland was higher. These results suggest that the land use intensity, it means deeper drainage, also the fertilizer use or presence of a livestock could further increase the rates of DOC production and losses. For agriculture purpose, peat has frequently been mixed. What happened? Okay. For the agriculture purpose, we also can find situation when the surface peat layer is mixed with the sand. It was done for creating better conditions in the case of the physical soil properties and also to ripening the cultivation crops. So it is an interesting study. The graph is coming from a very interesting study by Frank et al. From 2017. The authors showed that the DOC concentration in pore water was higher at the site with a peat sand mixture in the surface layer if compared to the shallow pure peat, as it is shown here. Now about the weather conditions and the climate. So dissolved organic carbon exported from peatlands appear to be climatically active. Thus the role of the temperature especially seems to be very important. And the temperature was reported as an important driver of seasonal variation of DOC concentration. So we can state that the higher temperature were also shown to enhance evapotranspiration from peatland, resulting in a rise in DOC concentration in the peat pore water. The presented graph, which comes from my study from the Grujec Valley, this is the fen peatlands area in the central Poland, also proved this situation, because if we see that the highest amount of dissolved organic carbon concentration in the soil we observed in the year 2018. And the year 2018 was very dry year because many European regions in this time, including Central Europe, experienced a prolonged heat wave and drought and was characterized by unusual hot summer. The same situation comes from the bottom table because also we can see that during the summer period, we observe the highest DOC concentration in our soil. So it means that the temperature is the crucial driver among the weather conditions, in the case of weather conditions, if we analyze this situation. What about the water table level? Number of studies documented the importance of water table level fluctuations in DOC productions. However, the most number of the study were conducted on the agricultural use peatlands where the water table level was close to the surface or within the root zone. So it means within the 0 to 30 centimeter zone. And in this situation, of course, we can say that the water table level is a very important factor in producing of DOC and then further controlling the DOC export. But what in the case if you have the water table level very, very deep? For example, our study from the Grujec Valley, where the mean water table level during the year was something around 0.8 meter to even 1 meter below the ground surface, it means that the marsh layer, which is very characteristic for secondary transform for a degraded peat soils, is totally above the water table level, so it have no connection with the water. And in this case, we observe that the water table have a very minor impact on the DOC production, and this process was especially conducted or affected by the weather conditions in this case. Another factor is the vegetation. So vegetation, as it is widely known, the dominant vegetation provides a variety of food sources for below ground decomposer for a microbial communities, affecting organic matter transformation, of course. So in particular, vascular plants, which dominate in the fen peatlands, may supply a lot of labile C forms to the peat soil system, what further affects microbial composition and its activity, which are, of course, responsible for the organic matter transformation. On this graph, we can see the effect of work by Schwalm and Zeiss from 2015, and they show that if we compare different vegetation, they compare Carex, Phragmatis australis, Zea mice, and when on the peatland with the 40 centimeter water table level and with the no groundwater table level, they see that the highest DOC production is observed in the case of the Zea mice plantation. So we tend to have a higher DOC relay than the soil cover with the Carex in this case. And authors explain this situation that most likely Zea mice deliver easily decomposable plant litter and root exudates to the soil microbes. Another very important issue in relation to the vegetation is the microtopography on this area. As you know, Carex is very important and widely common on fen peatlands ecosystem plant, and it's creating the micro relief. That's why one of the study presented by Wang et al. In 2021, this is very fresh, show us the differences of DOC production between the hummocks and the hollow. And the author state that the DOC production was much higher in the hummocks if compared to the under hummocks and hollow situation. And what about the microbial activity and structure? So all previously mentioned biotic and abiotic factors have direct effect on microbial structure. So we can say that the temperature is driving the microbial activity, the water table level also, the vegetation also, and so on. So this is also very complex and quite nice interaction between each parameters. And we can say that among the microbial genera, the most important for soil organic matter turnover are fungi and actinobacteria, which are the main producers of phenol oxidase and hydrolyze enzymes. Specifically, the low phenol oxidase activity under the waterlogged conditions leads to the buildup of phenolics and thereafter inhibits the activity of hydrolytic enzymes. And here on the screen, you can see some examples of the actinobacteria on the photo on the right side of the slide and the fungi at the bottom. And on the left side, you can see the microbial activity involved in the hydrolyze and phenolics production proposed by Freeman et al. In 2012. What about the soil properties? I especially show it right now after describing the climate, water conditions, microbial activity, because this is the last thing which can be directly or indirectly affected by the previously one describing factors. So among the soil properties, the most important drivers, or the most citable drivers in the available papers is soil organic carbon, the moisture of the soil, the temperature of the soil, ionic strength, pH of the soil, and of course the degree of decomposition. And mentioned factors are in the very close relationship and may interact between each other. So for instance, the high soil temperature may cause higher evapotranspiration, which in turn induce lower pH and higher ionic strength due to the sulfate formation, for especially in the soil. And it will also accelerate the dissolved organic carbon production. And now the difficult question, what is the most important factor? Especially I choose this kind of presentation with using these gears to put your attention that we have to be aware that all of these factors, which I already described, are in very close connected between each other, and they are interact between each other. So that's why this strong interplay between them makes that it is very hard to distinguish the single factor responsible for the DOC production and further for the DOC export from peatland soil. But in my opinion, and it is also postulated in the recent papers, the most important factors indirectly affect the DOC are the human activity and weather conditions. And we said that much more now we have to put attention to the weather conditions, which further will affect the water level, vegetation, and finally the soil properties and the microbial activity. So, do we have any alternatives? Because we all know that we still have to use fen peatlands as agricultural land in the case of croplands, in the case of the grasslands, meadows, pastures, and so on. But what is the alternatives? It was already mentioned by Stefan in his presentations, and one of the alternatives is paludiculture, the wet agriculture. So it seems to be the best option because this management system require high water level, but if we require high water level, also we have to choose a proper species of plants that can grow. And the proposed species of plants that can grow on the paludiculture, in the paludiculture are reed, Phragmites australis, catile, black alder, or the peat moss, but the peat moss is not so typical. But by the peat moss is typical for a peat box, not for a fen peatland. So in this case, this is not so good example. Okay. So is wetter is better? This is very nice question because we have to answer. It's really if we make that the groundwater level will be high, close to the surface, it will brings the better conditions on the fen peatlands, because a lot of papers pointed that dock losses from peatlands actually increase in the immediate time post-rewetting period. But the immediate is very important word, because if we are going farther into the long-term monitoring of this process, we can say that in the perspective, the rewetting driven the low rates of decomposition caused by water saturation, leading to the anoxia, which inhibit the activity of aerobic decomposers. Furthermore, we can also say that the rewetted peatlands may cope better with the extreme weather conditions that will occur more frequently in the future than their drained counterparts. It was postulated by the Schwiga et al. In 2021. So at the end of my presentation, I would like to quote a sentence by Professor Hans Josten from the Greifswald-Meyer Center, the world leader in the peatland research, that peatland must be wet for peatland, for the people, for the climate. So I think that this sentence perfectly describes the future needs for a sustainable peatland management in respect to climate change mitigation. So thank you very much for your attention, and I am open for eventual questions. Okay, we have one question from the audience and the second one. So the first question is, you mentioned shortly that in heavily drained fen sites, the process occurs in the surface soil layers are mainly driven by water conditions. Could you explain it with more details? Okay, but I think that I mentioned that not by water conditions, by the weather conditions, because if we have very heavily drained soil, so it means that the water table is very, very low, and the surface parts of the soil in which are mainly we determine the DOC concentration do not have a contact with the water table level. So in this situation, if we had such heavily drained soil, the processes occurs in the surface soil layer are mainly driven by the weather condition, especially the temperature. We proved such situation during our long-term monitoring on the agricultural peatlands, on the agricultural use peatland in the central Poland. So I hope that you are satisfied with this answer. So the next question, what is the percentage share of fen peatlands drained for agriculture purpose in Poland? Thank you for this question. So we know that the total area of peatland in Poland is something around 14,000 square kilometers. So it was reported by Professor Kotowski in 2021. It is circa about 75% of them are drained for agriculture use. So if we calculate that 75% from this almost 15,000 square kilometers, it gives us around 11,000 square kilometers. Yeah. So it is also worth to note that in the last year, we observed increased conservation of grasslands and pastures into croplands. So mainly corn plantations. So this is not so good situation that we observe this conversation. And what should be also connect with the climate change, yeah? Because if we transform the grasslands and pasture into the croplands, such ecosystem is much more vulnerable to export the carbon from it. That's why it is not so good in the context of climate change. Okay, the next question from Iman Yavadzarin. Thanks, doctor, for this presentation. Can we use DOC changes through time in inland water, such as stream and rivers, as an index to survey the degradation degree of peatlands? Yes, very good question. As of course we can, because if we observe, okay, first of all, we have to think about such situation. We have very strongly degraded peatland area, yeah? And in the surface soil layers, we have a lot of potentially labile organic forms, including, of course, these organic carbons. And if the situation, we have the very massive rain, or we start the rewetting of it. So immediately after the rewetting or a very massive rain, a lot of this carbon will be fluxed from this ecosystem and transported to the surface waters, to the river, and finally to the oceans, to the sea. So for sure, we can say that the DOC concentration in inland waters is a good indication for the degradation degree of peatlands, yes. Okay, another question, we still have 2 minutes. Yeah, I control the time. So it's from Christina. Dear doctor, please, does rewetted peatland differ in their biodiversity from the natural peatlands? It is a very difficult question because everything depends what type of peatlands you want to rewet. A different plant species will occur on the fen peatlands, different on the peat bogs, and so on. So if you ask that the biodiversity from the natural, of course, yes, because one of the first effect of the degradation of peatland, of the drainage of peatland, is the fragmentation of naturally occur peat forming plants. This is mainly, how to say, it's mainly switched by the grassy vegetation, some shrubs and so on. That is why the biodiversity, if you compare degraded area with the natural area, is totally different. And the last question from Paweł Rutkowski. Forest peatlands cover about 0 to 0.7% of total forest area of Poland. Honestly, I don't understand your question because it is kind of a statement, not a question. Okay, so in this case, if you will have any questions, so please call me or write me an email after, because honestly, I don't understand your question right now. Okay, so thank you very much for your attention, for the question to my presentation. And now we can go to the presentation number 7. And it will be the presentation about the salinity versus sodicity matters in Africa. Are traditional and scientific practice equally resilient? It will be given by Professor Jean Diatta, the head of the Department of Agriculture, Chemistry and Environmental Biogeochemistry at the Poznań University of Life Sciences. He does research in soil science and agronomy, especially. He cooperates with several scientific institutions, and he is a member of the Environmental Institute of Scientific Networks in Germany, the Polish Association of Agronomy, and played the role as the university representative for cooperation with African University. And moreover, Professor Diatta is an expert at the Polish Committee for Standardization in the section of soil chemistry and physics and fertilizers. So please welcome Professor Jean Diatta. Yes, do you hear us, Jean?
Okay.
Okay, now we hear you, but please make the full screen mode. Because
okay, just a while. Okay, I think just a while. Okay, is it okay now?
Yes, perfect.
Okay, thanks a lot. I want to thank organizers for this conference. This is the second time. Last year, Professor Spychalski has been inviting me also to to participate and some topic about soil conservations and traditional methods. I think and some ideas have been given that okay, scientifically we have sometimes the so-called traceable informations, and in terms of traditional, sometimes you used to say, okay, it comes and we don't know where it goes, but sometimes it is confusing. And this topic about salinity and solicity matters in Africa. And just this is to ignite some, how to say, brainstorming, because the science in terms of salinity and generally, okay, because the literature, scientific literature is mainly based on salinity, but if just we observe the effects of salinity, we see that salicity also matters. And much more, I would like to thank also the participants. I think that some of them are students, and also some our students of Poznań University of Life Sciences. And as you may be observing, the authors or co-authors of these presentations, they are also students who were just involved in seeking for some questions about the so-called solicity. Is really a matter that solicity is much more important or not than salinity. And next, the resilience. And I think that both options, that means salinity and solicity in terms of resilience, they are very complicated matters, as we will be observing, and not only in terms of science, not only in terms of traditional, but in terms of the effects, which sometimes are very, very harmful. Okay, first of all, talk about soil salinity. Basically, we should just focus on the so-called precipitations, because this is a matter of water. And then if we have scarcity of water, unfortunately, we should have the so-called capillary rays. That means this is natural, this is normal. And science has shown that these processes are worldwide known. But in case of Africa, as we see by these colors, unfortunately, we see that the rainfalls are very, very low. Only in this area where you see quite a bluish or blue, that means about 1/5 of Africa can be evaluated as okay, optimally covered by rainfall. But about 60, 70%, unfortunately, in many, many cases, in many, many areas, the continent is unfortunately suffering from the lack of water. This is, of course, not the topic of this presentation, but it is one pillar of the effect which is affecting basically the solicity or the salinity. And next, when you look at the continents, we have just all this continent which is being hit on both all sides by oceans. We have Pacific Oceans, we have Atlantic Ocean, which are highly salty. And even the Pacific sometimes ocean is much more salty than this ocean, Atlantic Ocean. What that means, we have the process which is known, the so-called low tide and high tide. And all these countries which are in Africa just at the seaside level, they are being communicating with oceans, and they are suffering from all these processes, low tide and high tide. And when this saline water enters the areas, unfortunately, we see that salinity is just coming. And this is one of the topics which is being connected with the low precipitations, unfortunately, is squeezing the problem of the salinity. And just this is some, let's say, just a sum up of the countries in Africa which are suffering. Most of them, they are suffering from salinity or even salicity. But when you see at these red dots, we have here the Libya, we have also at the border with Algeria, and we have here this place, Sudan, And also in nearby, we have Ethiopia, we have here Togo, we have Nigeria, and as you see, we have Kenya, Tanzania, and so on. But please believe that the whole continent around, they are more or less just being hit by salinity or sodicity. But now the urgent places in Africa which are really seriously under salinity control or salinity pressure is Ethiopia and this Togo. Togo, sometimes it is used that, okay, it is told that 60 to 70% within the next 10 to 20 years will be, unfortunately, be lost by the areas by the salinity. And now Ethiopia is building since the last five years, one of the biggest dams in Africa. Now we can know why Ethiopia is building this dam, because the higher salinity, if not Togo, this is Ethiopia. And this water is needed to mitigate really the salinity in Ethiopia, okay? And just now, if you take information by continent, because not to focus only on Africa, but to make some comparisons, salt affected soils in drylands, okay, by continent. We see we have saline soils, but the definition of salinity in terms of African continent is complex, and the salinity sometimes is also on the other side connected with so-called man-made salinity. That means by irrigations, not wisely done or excessively or something like that. Means, but naturally, the continent is just under pressure of here. What we see, that means sodic, because sodium, which comes with ocean waters, is being retained in land by water, which at the so-called low tides went back to the oceans. That means the sodium remains. And the sodicity and the salinity, which is sometimes made, they are very complicated. And in terms of how to say, remediating these soils, priority is given to the so-called scientific methods, okay, which are soon I'll be showing about the use of some chemicals to reduce or even to mitigate. But if you compare these saline soils, Africa is hidden. What that means, this is a problem of productivity, okay? And next, if we have, for example, about 1 million, 1 million hectares worldwide, that means which are evaluated as salt affected, we see that it is 1/5 of this area. And if you take the whole continent, which is now about 1.2 billion or 1.3 billion inhabitants, and 1/5 of about the area is being, unfortunately, saline or sodic, this is a serious problem. We have the drought, we have the salinity, and now the problem which we'll be facing, how we can be, let's say, strategically under resilience for plants, because now we are heading a serious problem. That means which plant will be surviving first, water scarcity, that means droughts, and the much more complicated salinity. And now sometimes scientific are just heading to grow, that means plant breeders plant the so-called halophytes, that means to go actively to accommodate these soils, because water is being a problem. That means limiting factors, because water for drinking purposes and water for irrigation, which is the most important here. That means urgent to give people water to supply for drinking, for housings, or to use this water for irrigation. And now at the whole continent, some countries are just developing some the so-called plants, technical plants, that means to perform the so-called desalination of water for using for household, and the other waters, that means for the so-called plant growing. And these areas in Africa are common. Okay, today I was just looking about the permafrost and the water, which are the so-called under temperate conditions, where just I was just dreaming even to have 1/10 of such potential waters even to African area, and to survive under such conditions. And these are not desert conditions. These are the so-called the Sahelian conditions. And these are really so complicated for these people. And if, unfortunately, they are saline, now you can imagine what is the fate of these people. First, lack of water, as we see now, and now they are saline, okay? And the use of traditional, because also by within preparing this lecture, there was some information, traditional or indigenous. And particularly, I prefer to use this option, traditional, because it covers much more, let's say, approaches, social approaches, and even some progress than indigenous. Indigenous is much more, according to me, much more local, and the knowledge is closed and sometimes for many reasons not to be shared. But when the tradition, sometimes it is much more open to outside. But coming to Africa, about the salinity resilience. For long years, the drought I was talking about, even from the 50s, there was some precise focus that within the next 50 or even 60 years, Africa will be suffering from the lack of rainfalls. Now, about 80% of the whole continent, and even in some areas, even 90% of the whole continent is providing its agriculture under rain-fed practices, rain-fed. Irrigation, it is costly. It was not, unfortunately, being just organized through the long time. This is why now, when people are facing such weather conditions where the temperature rises and unfortunately rains are unfortunately very, 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 very low, and now there is no rescue. Where? That means there are no system of irrigation. And this is why just I was today very, very glad if, okay, such potential of waters could be even 1/10 for Africa, but this is only a wish and will. And now this resilience for such a long time, how farmers have been facing such salinity, where they have not even been not being supported by, how to say, water irrigations or pipelines for water, some channels, and even for sprinkling irrigations. And these, they have got some knowledge to know the value of the soil, and also to make some natural or traditional selections of the grains of the plant by observations, which were really very, very important in surviving, even without getting such the so-called typical scientific support and so on. And let's have this table to sum up particularly what happened. And within the whole time, we are some, how to say, not confrontation, okay? Maybe some supply or some expectations. And we have the Western and the formal science. We have the so-called indigenous knowledge, IK. And here, when you see how it is documented, that means written, formally documented. And now let's come to the indigenous knowledge, that means the traditional knowledge. We have, it is oral, it is repetitive. Now, according to us, okay, since it is oral repetitive, that means it's scientific value, its time scale value, and its environmental value is quite very, very, how to say, weak, or even it is known, since the oral transmission is unfortunately sometimes highly complicated to repeat. Sometimes when you repeat, it comes maybe with changes. But now, if you come to the methodological and epistemological differences, let's have a look. It is systematic in terms of the science we are now just practicing. It is systematic, objective, and analytical. Okay, we have this well scheduled view of functioning. And now let's go to the so-called indigenous or traditional knowledge. It is closed, non-systematic, and holistic rather than analytical, okay? It advances on the basis of new experiences, but not on the basis of deductive logic. That means at this level, we see that we have not to pay attention to this, how to say, possibility of knowledge, since we have just at the beginning being just pushed away. And please believe from the ancient time, all of this knowledge, they were just, let's say, being interconnected, and it depends now which of the knowledge was saving these people when they have not been facing, let's say, universities, labs, and so on. Their own knowledge, traditional knowledge. Okay, and on this basis, I have tried to make some small concepts about solicity and salinity, and also the process of resilience. And the science practices focus on chemicals and water management, okay? These should be at once being managed, chemicals and water, because chemicals are sometimes worse if they're applied without water, okay? Water can be applied, but chemicals without water, it is worse for these salinity soils. And now water management by irrigation, by installations, all these things must be both being well managed. Now, let's come to another practice from science. We have plant breeding, observations and selections. Observation and selections, just both are well scheduled. Now, if you go to the traditional or the so-called the indigenous practices, rain-fed water management. If it rains, okay, we manage the water. If it is not raining, unfortunately, we have no water to manage. This is very complicated, and people are mostly being organized and, let's say, just thinking how to survive with such fluctuations of water, okay? Because they don't rely on water management if this water is fluctuating, rainfalls. And the next point is also observation selection. But now we have some proofs that the plant breeding processes, we have the gene banks, and scientists, they know gene banks, they are taking knowledge from the so-called traditional practices, which were surviving hundreds of years by selecting, by observing, but it required a much more longer time. There was just a huge report which was being prepared for saving this, the so-called indigenous knowledge. It is very interesting, and even weather forecasting, okay? How people, they observe the locusts, even animals, even trees, even many other, how to say, environmental organisms, which give some informations about the droughts, about the intensity, and even floods which are coming. And it is very interesting, this knowledge, which sometimes it is being proved by the science, but typically, traditionally, it is used to make some focus even on the process of salinity, even shortage of water. And now, how to define this indigenous knowledge? It is how to say, systematic body of knowledge acquired by local people through accumulation, okay, of experience, informal experiment, and as we see here, understanding of the environment, okay? Now we see that we should understand our environment. Is it the main pillar to understand many, how to say, challenges? I think observations, they take time, but also they give, how to say, result. And knowledge soil, please believe that it is so, how to say, emotional when you see that even these local knowledge are even in terms of soil science, they have their own knowledge. And we'll be seeing just because it is being developed in South Africa as the main organizers to save this African traditional or the so-called indigenous knowledge. And two options are being just focused on the knowledge of soil types. The color, okay, now we know even in modern science by the Mansell and others, and the texture. And please have two examples. Black clay soil is rich in nutrients and good for cultivation for maize, for pumpkin and goats. Okay, that means a knowledge is given that these soils are allocated for such plants. And now we have sandy soil is good for beans, for melons and sweet ridge. Okay, if you go into soil science, we know that, okay, this is sticking, okay? Both this knowledge is sticking. Now the question, how they knew about this, okay? And now this is only a short sum up of these names. As you see, you have local names which are given to these soils, and the texture also, clay, we have the names, typically the South African names, we have the color, we have reddish, black, dark, black, red, and so on, and uses for agriculture. And even here you have plastering, we have for constructions. And what is also important in this, we have also principal crops, which are dedicated for these local names, and also the fertility, which is in many cases being disturbed by salinity or solidity. And if you have high fertility, and this is, remember just now, for maize, for taro, for beans, if you have moderate to high sweet potatoes, maize, if you have for moderate beans, that means the knowledge is just on. And without this, even scientific, how to say, basis, lab, university, academician, these people that we locally, they have developed traditionally the knowledge which help them surviving many, many tasks and challenges. And just the World Meteorological Organization 2020 about the state of climate. Okay, I'm not going. This is not to come to give information about the climate, but basically how this is impacting and how locally people are being selecting some plants which for a long time are just their own plan to survive. And this is, I think, is very important. But let's have a small view here, and millet and sorghum. Okay, now our science knows that, okay, millet, sorghum, they are these plants which are at the type of C4, highly growing.
Jean, sorry, we still have 1 minute for your presentation because I also want to ask you some questions later. So please.
Oh, okay.
Yes,
okay.
Yes.
We have some maize. Okay, I'm negotiating 5 minutes because 5 minutes if possible. Okay, we have the sorghum and the rice. And next, these are the plants which we have here, as you see, rice and sorghum and pearl millet, which these people are using for their purposes, okay, with the long time. And this tree, Parkia biglobosa, is the so-called the nere tree. It is very important, and please look at the color of these pods and these husks. They are very important. And what is important in this? To fight the salinity. Husks, they have high concentration of tannins, and these are hydrosoluble, and these compounds, they are also coagulating, aggregating properties. And saline sodic soils, as you know, they are dispersive and alkaline, and these people, they have developed such knowledge to use this for such healing their soil which are saline. And also the paddy soil salinity, let's go through in Senegal. Last year, I was presenting another option of this community, which has a high knowledge. And as you see here, the mangrove soil, this bottom, these mangroves are growing on very saline waters. And we have ports, your field, paddy fields for rice. And the water which is to be managed is the saline water. As you see, it is just in front of these areas. And the most important is here. These fields also are being, how to say, prepared to retain water. Why such a strategy for such small plots, or let's say fields? Subsoil most frequently is clay, okay? And the strategy is just to have such subsoil clay and to reduce the capillary rays, which unfortunately is being hitting these fields. And this instrument is typically done not to go deeper than 20 centimeters, not to break the so-called, the shield of the so-called capillaries, since these fields are just being in nearby the so-called saline water. And science and solidity resilience, this is because we are short in time and we have what was done just about solidity. I was explaining this, and particularly I want to show something important. The capillary rays we're talking about, and we have the so-called saline seep. That means water and water timetable, which activates this process. And just for students, particularly, and the reclamation of these sodic saline waters. We have gypsum, which is scientifically known as some counter factor for such processes. And we have sodium, which is a dispersive agent, and we have also calcium, which acts as some coagulants. And these are data which, you know, we are short in time, but please focus on this saline soil. That means this range of salinity, reduction of yields of sensitive crops. But if this is the reality, let's have a look for cotton, peanuts, the ranges we have, rice and soybean, and students and a team I have shown at the beginning was simulating
15 lat temu, to jeszcze można by było
observations. And here we have the so-called induction of salinity.
Jan, sorry, you are out of time. Excuse me.
Okay.
Shortly finish.
Okay, let's 1 minute I negotiate. Only 1 minute. And here we have the soil, 6 soils, and where we have been simulating some salinity. We have 5 soils, we have sodium, calcium, and so on, and 2 plants. And please have a look what comes next to these. Plants are growing, and the level, that means of salinity, that means at 4.0, which is the fence, that means of salinity. Here plants even are growing even when we have more than 4. Next, we have also the salinity, solidity by sodium nitrate. We are also plants which are growing normally even at 19, and here the threshold was 4. And when you go, we have carbon, sodium, sodium carbonate, and now we have also 4.4. We haven't plants. And next also we have gypsum. We see all the plantation. We have all the plant even at 4 here. This level have even at salinity at 30. We have even some plants which are growing, and we have also the so-called urea. Urea has been given, but also at this level up to 4, 5 we have plant, and at salinity 6.78 we have quite no plant. And finally we have this humic morsic soil, and we have added some sodium chloride, and we see just even at 4, 3.5, even about 9 we have some plants. And finally the conclusions, these knowledge are interactive, and we cannot omit the so-called indigenous knowledge. And thank you, sorry for this time.
Dzień dobry panu.
Short enough. Thanks a lot, and Sorry for
Tą jednostkę akurat
abusing the time.
marketingowo idzie, nie?
Thank you very much,
rzeczywiście
Jan. Yes, as you mentioned, you run out the time, yeah, totally.
Exactly.
So that is why we do not have time for any question, even very small ones. So if somebody wants to ask question to Professor Diata, please send an email to him. I'm sure that he will reply soon. Yeah. So once again, Jan, thank you very much for your contribution to this conference and for your nice presentation. Thank you.
Okay, thank you. Thank you a lot. Welcome. Thank you.
Okay, so now it is time for the last presentation for today, the presentation number 8. It will keep us with the problem of saline soil, but now we move directly to Poland, to the Polish conditions, and the authors from the Nicolaus Copernicus University in Toruń, Professor Piotr Hulisz and Professor Agnieszka Piernik, prepared a very interesting presentation entitled Natural and Man-Made Hazards to the Saline Coastal Habitats in Poland. The presentation will be given by Professor Piotr Hulisz from the Department of Soil Science and Landscape Management from the Nicolaus Copernicus University in Toruń. He is a soil scientist and geographer. His main research interests related to salt-affected and acid sulfate soils, soil classification, and soil-plant relations. So please welcome Professor Piotr Hulisz.
Oh, yes.
Okay, we see you, but we don't hear you. Piotr, please unmute your microphone.
Yes.
Okay, now we
Thank
hear
you
you.
very much. Can you hear me and see me?
Yes.
Okay. So I start my presentation. Is it okay?
No, we do not see the presentation. Please share your screen.
No, ja poproszę 180 osób.
Okay. Now we see it in the work mode. Please make the full screen. Okay, perfect. So
Okay. Okay, thank you very much. Good afternoon, ladies and gentlemen. It's my pleasure to be virtually with you today. Thank you for inviting me to this conference and for giving me the opportunity to talk about saline habitats in Poland. We can say that they are very rare in Poland and have very specific features. The aim of this presentation is to characterize both abiotic and biotic components of saline habitats in Poland, with a special regard to natural and anthropogenic hazards to them. This topic is closely related to our scientific interest. As Bartek said, I'm a soil scientist and geographer who deals with salt-affected soils. My colleague, Professor Agnieszka Piernik, is botanist, ecologist with a background of soil science and the halophyte specialist. I hope you will find this presentation interesting. I divided my presentation into 5 main points. First of all, I'd like to give you a general overview about saline habitats over the world and in Poland. Then I'll focus on driving factors of salinity in the Polish seacoast. Next, I'll be looking at ecological value of the coastal saline habitats. And finally, we will move into the point which concerns the utility value and main hazards. It's good idea to start with the definition of the saline habitats. According to Poliakov, Maber, Lerner, we can define the saline habitat as habitats which have soils which contain a high percentage of soluble soils, mainly chlorides, sulfates of sodium, calcium, and magnesium, and one or more these salt components is usually present in excess. As you see on this map, the majority of saline areas occur in the dry or semi-dry climate zones. As Professor Diata said, that estimated total area is over 1 million megahectares. But in contrast, to these areas. The occurrence of the Polish saline habitats is associated with the percolative type of the water regime in soils. The typical salt accumulation does not take place as in case of the arid and semi-arid climate zones. Therefore, the occurrence of saline habitat in Poland is not conditioned by climate factors, but the stable inflow of waters with high mineral content of natural or anthropogenic origin, of course. Let's now turn to the natural and anthropogenic factors of salinity in Poland, which are crucial for the functioning of these habitats. So among the main salinity sources, we can distinguish the seawater and ascending saline waters in the coastal areas, ascending saline waters in inland areas, and industrial waste and brines in Poland, yes. The estimated total area of saline habitats is about 100 kilometers. It's a very small area comparing to the salt-affected areas over the world. But we can say that the occurrence of these habitats in Poland follows the spot pattern. We found about 100 sites, areas from less than 1 hectare to a few hundred hectares. So it is very, very specific situation. As you can see on this picture, the saline coastal, we also call them marsh soils, are distributed across the following southern Baltic Sea areas, like Szczecin Lagoon. Here, for example, in the reverse delta on the Świna River, in the Kamień Pomorski Lagoon, as well in the Puck Lagoon, Vistula River Delta, Vistula Lagoon, and in some places at the bank of the coastal lakes. Some of these soils have developed under strong human impact, especially as a result of the hydro-technical works, for example, construction of river channels, flood banks, and breakwaters. Such soils can be found in the artificial mouth of the Vistula River, as well in the Marzęcino Polder, the Vistula Lagoon in this place, and in the Karsiborska Kępa Island, the Szczecin Lagoon. What about the Baltic Sea? As you know, the Baltic coastal zone in Poland has very specific features that are predominance of the cliff and sandy coasts, generally no tides and brackish water conditions. The salinity of the Baltic water is relatively low, as you can see. And according to my study and my colleagues, we can find the brackish marsh soils in the lagoons and river mouths, and in some places there are also potential and actual sulfate soils. And here we have two examples of Polish seacoast landscapes. And the next two slides show the saline areas slightly away from the shoreline, affected by infiltration waters coming from the older geological epochs. So please take a look. First example, the Szczecin Lagoon and beautiful landscape of the reverse delta of the Świna River in Świnoujście, Kaszibur Island. There we have indirect influence of the seawater as backwater. And another example, brackish marsh areas, the Puck Lagoon, in Brzezino, halophyte reserve Beka. And this type of the landscapes is very, very specific, and it looks like the lake, not like the sea. And the next one show the areas affected by the paleo infiltration waters. I mean the waters which infiltrate from the older rock deposits, yes, groundwaters. Chrząszczewo and Kamień Lagoon and Kołobrzeg Budzistowo, probably the most famous place. Well known as the first place, first salt mine, yes, in the Polish history. In this, okay, let's now look at the next slide, which shows the profiles of the coastal saline soils. There are shallow soils, as you can see, developed from very stratified deposits, which reflected the changing conditions of mineral and organic matter sedimentation. Due to the specificity of the Polish coast, their occurrence is limited only to flat coastal sections of the Polish coast, including delta plains. In this part of my presentation, I'd like to talk about ecological value of the coastal saline habitats. First, I'd like to stress that the salinity is responsible for the osmotic stress, which is caused by the excess of natrium and chloride ions in the soil that decrease the osmotic potential and limits the water uptake and nutrients by plants. The halophytes are plants which perfectly adapted to the salt stress. Here we have some examples of the definitions of halophytes. The last one is my favorite because it's the simplest. So according to this definition, we can say that halophytes simple plants that can survive on high concentration of salt in the rhizosphere and grow well. Very simple, but very nice and clear. Okay, halophytes, we know that halophytes are indicators, can be indicators of the soil salinity. So here is an example from the study of my colleague Agnieszka, co-author of this presentation. As the graph indicates, the common glasswort, I mean the Salicornia europea, can be considered as good indicator of the high soil salinity level because the occurrence spectrum is the maximum yes, is at very high salinity level. In general, the Baltic saline wetlands are considered to be valuable and endangered ecosystems. They are designated as habitats of European importance according to European Union Habitat Directive and included to the Natura 2000 network. They are also protected by the Polish law. And the coastal salt meadows are a common type of saline habitats which occur in the Polish coastal zone. There are also two subtypes, halophilous meadows and pastures, and halophytic rushes. The next slides show photos of typical plant species for halophilous meadows and pastures and halophytic rushes. Yes. Plantago, Sperguaria salina, Puccinelia distans, Juncus gerardi, Glaucus maritima, Triglochum maritimum, Aster triporium, Plantago coronopus dominate in this subtype, and Balboschenos maritimus, Schoneplectus tabarnemontani, and Agrostis tolifera is typical for the second subtype. Special areas of conservation protected according to European Union Habitat Directive are described in this table. So as you can see, we have six areas protected according to the Habitat Directive with halophytes. I mean, Ostoria Słowińska, Trzebiatowsko-Kołobrzeski Park Nadmorski, Ujście Odry, Zalew Szczeciński, Wołyń i Uznam, Zatoka Pucka i Półwysep Helski and Dorzecze Parsentdy. Okay. And in Poland, we also have 4 coastal reserves of halophytes, Słone Łąki, Władysławowo, Mechelińskie Łąki, Beka and Karsiborska Kępa. Please look at this slide and notice that some saline habitats were also included to the special protection areas of the Natura 2000 network. There are very many rare birds, for example, Acorocephalus paludicala, Tringa glaola, and Calidris alpina shinzi. Let's now turn to the last point of my presentation, which concerns the value of the coastal saline habitats and hazards connected with the land use. First, however, I would like to remind you what is the main goal of protection according to the Natura 2000 network. So we can say that the purpose of protection in the areas of the Natura 2000 is to maintain the natural habitat types in the favorable conservation status. It is quite different comparing to the conservation status in the reserves of the halophytes, for example. Because the conservation status of the natural habitat will be taken as favorable when its natural range and areas covered within the range are stable or increasing, the specific structure and function which are necessary for its long-term maintenance exist and are likely to continue in the future, and the conservation status is typical species is favorable. So it means that we can use this area, for example, for pasture for as a hay meadow, for example. The main problem is how to keep this favorable conservation status. And some examples, as I previously said, the saline meadows should be moved and grazed. And according to the Nature 2000 network, this is an active form of the protection of saline habitats. Why? If the brackish marsh areas is abandoned, the succession of Phragmites australis will take place, so it can even cause the total disappearing of halophytic plants. The very important problem is also to maintain an adequate supply of the saline water. Here we have an example from the Mechelinskie łąki from the Pucka Gulf. That some kind of the degradation of this habitat is caused by as a result of abandonment and lack of the conservation of the melioration system. Another problem are land drainage and urban development, which can lead to the degradation of habitats too. We found during our monitoring studies this year, we found 2 totally degraded sites in Kamień Pomorski, Wyspa Chrząszczewska Island, Wyspa Chrząszczewska, and in Kołobrzeg. So it was impossible to find halophytes in this place, and the salinity, soil salinity was very, 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 very low, and the most part of this area was covered by the buildings and
Piotr, sorry, but you still have only 1 minute left, so please.
Okay. And another problem is related to the coastal soils which contain iron sulfides called acid sulfate soils. From this map, we can see that acid sulfate soils occur together with salt affected soils. The problem is when we have the watering of acid sulfate soils, which leads to the oxidation of iron sulfides, which causes strong soil acidification. pH usually drops below 3.2 and enables the release of heavy metals to the environment. It is a particularly important environmental problem in Finland and Sweden. And let's now ask ourselves what changes on the Polish coast can we expect as a result of the global climate change and the sea level rise. This is one of the hottest topic right now. One of the simulations presented on this map, where you can see that the Vistula River Delta can be flooded with the waters of the Baltic Sea, as estimated in 2050. The question is, are we prepared for it or not? With regard to these changes, we have undertaken research which proved that black alder, Alnus glutinosa, can be considered as an option for planting in brackish coastal areas where the nature conservation and watershed management are at least as important as wood production. Okay, I skip these slides. And Coastal saline habitats need regular scientific monitoring, which includes the study of examination of soil moisture and salinity, control of management type and intensity, and assessment of the area size and richness of plant and animal species. And now we are approaching to the end of my presentation. I'd like to summarize my presentation running through the following points. Coastal saline meadows are characterized by high agricultural and natural values. The variation in soil properties, especially the salinity level, results in the occurrence of the different plant communities with rare halophytic species, which can play an important role as a bird refuge. Agricultural management by cutting and grazing is required for active protection of salt marsh habitats. Moreover, a natural and or artificial water regime should support soil salinity. Some coastal soils are highly susceptible to strong acidification. Therefore, any regulation of water relations should be carried out with care. More research is needed to assess the effects of climate change on biodiversity of the Baltic coastal saline habitats. Thank you very much for your attention and some references.
Thank you so much, Piotr, for your presentation. It was an excellent chance to hear about the potential hazards to saline habitats and further about active protection of salt marsh habitats in Polish coastal zone. In my opinion, a number of people might not even realize on the scale of this problem in Poland, and I am one of this person, especially. So, in this situation, we still have 2 or 3 minutes for some questions. Let's look at the Q&A section if we have any question. Right now we don't have any questions, so maybe I will ask one for myself, if you allow me. Yeah, so my question is, are acid sulfate soils in Poland contaminated with heavy metals? It is a problem of such soil?
Okay, very good point and question. Now we're still studying these soils. I mean the acid sulfate soils, because they are very unique, very specific along the Polish coastal zone, especially in the southern coastal zone in Poland. And first, I would like to remind you that intense leaching of metals takes place during dehydration of soils rich in sulfide minerals and poor in carbonates. Yes, so this is some kind of background. Yes, and some elements such aluminium, cobalt, nickel, zinc, cadmium, and manganese usually occur in the acid sulfate soils in amounts typical for non-contaminated soils. Yes, but however, they are largely connected with sulfides, whose intense oxidation in conditions of strong acidification significantly increases their mobility. So that is the problem, not the content. Content is very, very high, but the potential mobility, yes, of these metals.
Okay.
Yes, bound with the sulfides. Yeah.
Thank you so much for your answer. And we have another question from the Q&A section from Iman Yavadzarin, as I said before, the most active participant of our conference today. So the question is, has the recent trend of coastal salinity in the northern of Poland shown any significant effect on the vegetation biodiversity in this area? What is your opinion, Piotr, in this issue?
Okay, thank you for this question. So it's a very good question for my colleague. Unfortunately, is absent today. But as I mentioned, this year we did monitoring along the coastal salinity, along the coastal Baltic Sea coast in Poland. and we compare our data, I mean the soil salinity and some vegetation data, with the results of the monitoring from the previous years. Yes, I mean two dates, 2006 and 2015, and so we can say that we can see the clear trend, the clear relationship between the changes in the caused by the climate, global climate changes. Yes, but we can say that we revealed that the most important problem is the human impact. Yes, I mentioned about it. Lack of the pasture and hay. Yes, and bad access of the problem with the access to the water, so saline water. Yeah. This is the most important factors controlling the vegetation biodiversity in these areas.
Thank you so much for your explanation. Yeah. So
very difficult.
Yeah, it's very complex, so that's why it's hard to answer. Complex, yeah. Very easy and shortly. So thank you very much. We are run of time for your presentation and for your question time. So thank you once again for your presentation, for contribution to our conference, and that you being with us.
See you very much. It was my pleasure.
Okay, ladies and gentlemen, so all the presentations were present already. So now we have a couple of minutes for some additional questions. If you have some additional questions, especially to Professor Jandiata, because we do not have the time at the moment just after his presentation. So if somebody have a question to Professor Jandiata, please type it in the Q&A section, and we will make a host to Professor Jandiata, and he will be able to answer. But first we have to, okay, please maybe make a host to Professor Jandiata, and maybe I will ask about something, because his presentation was also very important, related to the saline soils, sodicity. So maybe we can ask about something. Oh, maybe we have some Q&A question. Yes, we have. Oh, great. So, Jean, hello again.
Yes, welcome.
Now we will have opportunity to answer on some questions. So the first question comes from Piotr Gajewski. Are traditional and scientific practice enough for facing salinity, sodicity challenges in Africa? What is your opinion in this case?
Yes, thank you very for this question. I think that as I have shown on my presentation, scientific practices and even knowledge is just how to say, to confirm something which was just existing before. And now just short explanation, 2 years, the last 12 years in Africa, they were planting the tree I have shown now, this the narrow plant, that means which has been just a huge potential for food, but also this the husk for salinity. And some millions of trees are now under plantation in the country, Mali, which is 70% under desertification and sometimes on salinity. And what I want to say, science now should be just stepping back to the so-called traditional knowledge, because plant breeding now, unfortunately, is facing the factors that changes, environmental changes are going quickly. And now even plant breeding is not just coming on to meet all these requirements, and the traditional methods, which were just being experimented for long years, they know which plant really are being adapted. And now I think that science has to cooperate tightly and strongly with the so-called traditional knowledge.
Okay, thank you very much for your answer. Oh, there is another question from Piotr Hulisz. What is, in your opinion, about haloculture as an alternative way for food production? Is the arid and semi-arid in the arid and semi-arid zones?
Once more, agriculture, because I lost this.
What is, in your opinion, about the haloculture as an alternative way for food production in the semi-arid and arid zones?
Yes, exactly. And I'm very glad that last year's even the area, the so-called the subtropical area, people are being experienced some so-called beans, which are resistant to basically saline conditions and beans. And next also, the haloculture depends now basically on the so-called area which is being impacted. And if the area, like the countries I have shown, for example, we have Ethiopia, we have Togo, and some part of other countries, this haloculture is expensive enough because the varieties which are being just selected for the so-called local farmers, unfortunately, they are not producing in terms of yield, a high yield, because you have biological barriers which are limiting the production of huge yield. And now, if the population is increasing and people now are just trying to force to accommodate this, the so-called saline soil, and they are facing sometimes much more effort, inputs, and the income in terms of harvesting are unfortunately low. But what is important, this is a way, and there are now plant varieties which are being accommodating these soils, and the people are now just being much more, ready to invest in this area. But there are sometimes social and psychological limits which make that people are afraid sometimes of these bare soils you see for kilometers, and now what to do there. But people are trying step by step to plant, and there are some forests, some typical plant forests which are being just planted.
Okay, thank you. Thank you very much for your answer, that you have opportunity to have these two questions. So now the official part, the presentation part is closed, and now we can go briefly to the summary of the conference and to the closing part of the conference. So once again, John, thank you for your attendance.
Welcome, thank you, welcome.
So first of all, we would like, together with Professor Spychalski, to thank to all speakers for their time, involvement in the preparation of the presentation, sharing their experience, expert knowledge, and participation in the discussion. All today presentation, of course, will be available in the materials which will be attached on the website in the PDF version just after the conference, so it will be freely accessible. And moreover, we would like to say the special thanks to my colleagues from the department, which were involved in the organizing of today's event. Without their help, we will be unable to prepare today's conference. And of course, I would also like to thank to all participants for their questions, for the lively discussion today on our very important topics we were presented. And thank you for your interest in participating in our conference. And I strongly invite you for the next edition in the year 2022. But maybe Professor Spychalski also want to add something from his side.
Also finish. Thanks you very much.
Yeah, I hope that all of you enjoyed the presentation. Yeah, they give us a new insight into the climate and soil interaction. So in my opinion, it was very, very important. And I am sure that today's conference increased our awareness that climate change has a major impact on soil, and changes in land use and soil can either accelerate or slow down climate change. Without healthier soils and a sustainable land and soil management, especially, we cannot tackle the climate crisis, produce enough food, especially, and adapt to a changing climate. So once again, thank you very much for your participation, for your nice question, and see you again in the next year in December in 2022. Bye. Have a nice afternoon.